So, assalamu alaikum warahmatullahi everyone. Today, as you can see, we are here for the applied numerical class. So, if I understand correctly from what I've gathered as information, you have three topics, mostly generally. So, you first have curve fitting. In question one, curve fitting, differentiation, and integral. Question two, you have either IBV or BDV, BV value problem, or BVP. So depending on which one you have, and then question three is the other one. So it's either IBP for question two or BVP. And so whichever one comes first, the other one will take for question three. So for now, we are going to start with the curve fitting. But before that, let me just write for the first one we have curve fitting, question one, curve fitting, differentiation and integration. We'll go through curve fitting and integration most importantly. Differentiation, we'll go into it briefly, inshallah. Then question two, supposed to have, let's say, IBP. Anybody knows what IBP means? If you have read the topic, the syllabus. Okay. IBP is initial boundary problem. BVP is boundary value problem. So we'll look into it. What is the difference between these two? And these two is either one. Question two can be BVP and IBP. So to make it brief. So for curve fitting, is it okay if I start now? Everybody is warming up or still? Hello, listener. For curve fitting, what you need to understand is that you are not here to draw a curve. That's the most important part. That's one thing students get wrong at first if they don't understand the syllabus. Curve fitting, what it means is that you have values and you have a graph. And from this graph and these values, you need to derive a function. Understand? So, why curve fitting? Field data is often accompanied by noise, even though all independent variables remain constant. A process of quantitatively estimating the trend of the outcome, also known as regression or curve fitting, therefore becomes necessary. So, the goal of curve fitting is for you to understand the process and to be able to predict whatever happens next. We talked about before control engineering, being able to control the curve and being able to understand. So when you have difficult equations, your goal, if for example you are supposed to analyze a graph, just like I have mentioned before, if you are supposed to analyze a graph that is just like this, and then you don't know how exactly to predict the next data, the next point. So it's a bit difficult for you without the numerical methods, basically. So you need numerical methods, and here specifically you need curve fitting in order for you to derive a function f of x. Now f of x can be quadratic, which is x to the power of 2, can be cubic, x to the power of 3, or can just be simple, linear, x plus b. Or also it can be exponential and all the rest, exponential and so back to the lesson itself. So the goal of curve fitting, you have, first of all, now that you understand what it is about, you have three methods overall to determine the curve. Okay, so what are they? Here is a collocation polynomial, which is the easiest and the most common one. I advise you to go for it. No, guys, they don't ask for any specific method. Least square regression statistic method. So that one is different for higher order. Usually they don't ask for question one. They don't ask for higher than second degree order. So you never really have to do this one. And third of all is interpolation calculus method. That one is not really asked because it doesn't show enough understanding of the subject. Interpolation is done for literally everything. You don't need numerical method basically. You will do interpolation. So regarding that, we have then question the test of 2024 and 2025. Okay. Why we start immediately with the test is because the theory here is very confusing at first. If you just look at the theory, it's very confusing. And usually you don't apply it as you see, as it is shown here. It's much easier for you to understand first. So we're going to start with the 2024, 2025. I already sent the test in the group. And so the question 1, what does it say? It shows the total mass of a variable density rod is given by m equals to integration L0 rho x times AEC. So this is a function, and this is related to what? Integration. This is the integral. So it says that where mass rho density AC, where mass m, rho density, and AC cross-sectional area are factors of x, are functions of x, and x is the distance along the rod. So we have different values here. You can see here. This one, etc. And you have missing values, most important. And so the first question says, for the given information, estimate the missing value using a numerical method with a second order approximation. So what's really the problem? If you see clearly, they ask for you to check the rho x here, not mx. Mx is later. For rho x is where you will need curve fitting. The first question, you have you may have all three, which is curve fitting, differentiation, and integration, or you may have only curve fitting, integration, or curve fitting and differentiation, or just like I said, okay. But curve fitting is coming for sure. So here, what does curve fitting say? Curve fitting says that if you already have data 0, 2, 3, 8, and 10, you can sort of develop a function from that and use that function to find the missing data here, 4 and 6. Understand or not? Okay. So what is really not understood so far about the problem? Is there any question regarding the problem? I think it's too forward, is it? Okay. Okay. The context of the question. Basically, like I said, for curve fitting, you are given a function first of all. Okay. The function has a graph. Sometimes, maybe doesn't. However, for sure, it has variables. It has values. Okay. So here, let me put again. Right? Okay. So for here, let me add the tab. So for here, you have a function that is first of all integral m equals to L0 for x AC. Okay. The slides are already in the group, I believe, isn't it? If somebody could reshare it, that would be really great. Okay. You have rho x and AEC of x. Okay. So for this one, first of all, you are required to find the missing values in rho x. Rho x is a function. Okay. The function, as you've seen here, has values. You are required to find the missing values. Estimate the missing values. Yeah. Okay. So let's say that rho is like this. The 1 is here, 2 is here, 3 is here, 4 is here. Then you are asked to find 4. What is 4? So usually when you have a linear equation, you have this one and this one. You take the values of, you have f. This is x. This is f. Just erase it. You have x. You have f of x here. You have x. Okay. Usually you just take these 2 points, right? Now, for the polynomial, asks you to do 2 things. You have multiple points, asks you to take up to 1, 2, or 3 points. to find this missing value. Yeah, you are supposed to find this missing value. So how do you come about this? This is the function row of x. You have x, okay? And then you are supposed to find row of 4, row of 0. So we start with A. Sorry. You start with A. You have row of 0 equals to, I believe, 4. Row of 2 equals to 3.95. Row of 3 equals to 3.18. Okay. Now they ask you, what is row of 4? Understand the question? No. Is it clear to everybody, the question? Okay. Now, for row of 4, curve fitting, you are supposed to use curve fitting. And that's what they expect you to do. Because you are supposed to determine the numbers which are x's. You are supposed to find the f of x in the curve. F of 4, f of 6, missing values. Do that, you need to do curve fitting. So you have multiple ways of finding it, like I already mentioned. So first of all, the easiest is to go for co-location polynomial. Easiest. If they don't ask you any sort of method, just go for that. For co-location polynomial, it depends. You have multiple orders. Whether it is ax plus b, ax squared plus bx plus c, etc., etc. And so here, what collocation polynomial does is basically it takes the values x1, y1, which is here p0 equal 4, x1, x2, y2, which is row 2 equals 3.95, x3, y3, which is row 3 equals 3.89. From these, it derives. Okay? So let me explain it easier fashion here. So, after you have extracted the values, why exactly? What does the question says? It says numerical order, second order approximation. What does this exactly mean? It means that the end equation has to be f of x equals to a 2x squared plus a1x plus a0. Why exactly? They mentioned second order approximation. And usually this is what they expect you to do, to get a second order equation. Always a second order equation. The end equation has to be f of x equals to a2x. And here it is actually row of x. So you can just dismiss that one and put row of x equals to a2x squared plus a1x plus a0. Clear? Okay. Now, how do you determine it? Once again, you know that row. Let me go directly then to my answers, since it's clear for everybody. I'm just explaining from there. So, strip the whole thing. Okay. So here, what it does basically, it defines that row x has to be, this is the second order approximation. They assume that row is a quadratic equation, has to be quadratic. So we put it in the form of a2 x squared plus a1x plus a0. So we have these three values. I extracted row 2, row 3, and row 8. Why exactly? Because row 2, row 3, and row 8 encircle 4 and 6. just to get a more approximate. You can get any three values you want. There has to be three values. Why exactly? Because you are supposed to use them to convert them into this matrix. How do you come out from here to here? You have this row to right. So row for x equal to, row for x equal to x squared equals how much? So you will have row 2 equals to a2, 2 squared equals to 4, right? Plus a1. a1 times still x here, huh? Times 2 plus a0 equals to how much? 3.95. So 3.95. Okay? So this is the first equation that you will have. You do the same for all three. So you will always have a2 here, a1 here, and a0. And you will have the result here, 3.95. So you have here 4, so which is 4, 4 times a2, 2 times a1, 1 times a0. Why 1? Because it's x to the power of 0. 2 to the power of 0 is 1. As you can see here. So 2 to the power of 0 is 1. Okay? So 4 times a2 is here already. This is what you get here. So if it's x equal to 3, we'll get what? We'll get this one. 3 squared equals to 9. And then a1 times x, row times 3. Again, why do we take only 3 values? Let's go ahead, Muhammad Faris. Hey, go ahead. You can use row 0 only. Yes, you can use any 3 values. There has to be 3 values because you need 3 equations. Why? Because you have 3 unknowns. Once again, so you can see here in the slides that here they needed to have a third order polynomial, right? I don't know if I can use red handwriting to text. Let's see. Okay, so they have a third order polynomial. Understand? So they have to use a3 times x cubed, a2 x squared, a1 x. But usually they don't ask. They never ask for third order. If they ask for third order, then this is how the equation should come out. So you take out these 1, 2, 3, and 4 values. Okay? These 4 values, you will use them for these 4 equations. Why? Because you have 1, 2, 3, and 4 unknowns. Now for us here, we only have 3 unknowns. A1, A2, A1. A0, sorry. A2, A1, and A0. I'm getting confused. Okay. So after we took our 3 values, we substitute them here because x is known here. What we don't know is the a's. So you have 3 square, 3 here, and 3 to the power of 0 is 1. Same goes for number 8. So you take 8 square, you have here a1x and 1. The results are already here. You know what row of 8 is, so you just put it here. With these equations, you have 3 equations that you will translate into matrix. Why? Because you need to show the steps. However, when you solve them, you don't put them in matrix in the calculator. You just solve them as simultaneous equations in the calculator. Don't worry about it. And so the calculators will give you values. So what are the values that you can find on the calculator? Can you guys calculate it as well? Or you guys are still confused regarding the equation? Can you guys find the equation or I write it down? Can you calculate it? Can you compute it? Shabab. Okay. I write it down or you already know how to write it down? Okay. I said you have this matrix. I already shown how we got the first equation. A2 times 2 squared. You substitute. this x here, and we already have the value. We have one equation for this first line. Done. Now we want this line and this line. Okay, then you guys do it. And you guys produce the equation and get the value. Or you want me to produce the equations? Okay. I'll show the equations here. Basically, the first part, as we already showed, the row of 2 equals to A is 2 squared. Okay? A2. You can name it anything. I advise you to just put it to understand. Plus A1 times 2 only. Okay? Plus A0 equals to 3 point, what did we find here? 3.95. So 3.95. Again, they ask for a what's it called? The values of 4 and 5, which are unique here. So we need to determine first the function rho. For curve fitting, if you already have the values here, x, row of x here, here, and here, you can just use them because they already said second order. So we have a polynomial for sure. We just put it in the form of polynomial. We take the values, we substitute only. That's it. So here, we already substituted number 2, right? The number 3, we have a2 x squared plus a1x plus a0 equals to something. So row of 3 equals to a2 also 3 squared plus a1. We have 2, 3. Okay, plus a0 equals to 3.85, I believe. Something. You check again. 3.89. 89. Okay, this is the second equation. The third equation, I substitute 8. Now let's substitute another number. For example, which number do we choose? This number 10, for example. It will give less accurate, but still. No, not less accurate, just different answers. Accuracy is depending on the real answer. So, number 10, it's not so far off. Number 10, so you have A2 times 10 square plus A1 times 10 plus A0 equals to, I believe, 3.3. 3.3. Yeah, 3.3. Let's add here 3.3. We have these 3 equations. 1, 2, 3. They are simultaneous equations because they have the same unknowns here. A2, A1. Now you find the values of A2, A1, and A0. That way, you can express the row X here. Row X, you can express it fully. So what are the values of A2, A1, and A0 based on these 3 equations? Can you compute it on your calculator? Yes, after you don't need to put it in the matrix actually. For me, it's just easier for me to visualize it. To visualize whether what I put is true or false. Because here I can see if I make a mistake, I can check here if I put the correct numbers basically. Because in the matrix, this is how you put it. You just put 4, 2, 1, 3 point. You don't put A2, you don't put A1, you don't put A0. So for me, it's just easier. But you can just take it directly from these equations and go ahead. Especially if you are limited in time, huh? Especially if you are limited in time. I love listening. So you have these 3 equations. So just compute them on the calculator simultaneously. If you don't know, if you change calculator and you're confused about it, you can check on YouTube as well, as always. You know what you find, huh? Abdel Ghani, you mentioned that you find ABC. What is ABC?
I think for A, I got minus 0.02.
Minus 0.02. What did you use for the first? Can you read me your simultaneous input?
Yeah, so like, let's say for the first round, like it's 9 plus 9, 3, wait. So like my first row is 9. Wait.
Okay.
Yeah, my first row is 4, and then 2, then 1 is equal 3.95.
Equal to how much?
3.95. The first row.
Okay.
And the second row is 9, 3, 1 is equal 3.89. And the third row is 6, 4 plus 8 plus 1 is equal 3.41.
3.41. Okay. And you get?
So like I get those values. Like for A, I got minus 0.02. Like, am I missing something?
For A, you got how much?
Minus 0.02.
0.02.
Yeah.
2. No, you're not supposed to get 0.02.
Okay.
0.06, yes. 0.058, yes. But 0.02 is too far.
Okay, and for B, I get 0.05.
That one also is far off. Okay, and then the third one is 3 point something, 3.9.
No, the first one I got regular number 4 for C.
Okay, the first one is 4 point. No. I'm talking about the results. The third one.
Oh. No,
the third unknown.
The first one, the third one I got 4 for C.
Yeah, 4 point how much?
Like 4.059.
Okay, so you seem near. I don't know why your values are far off for the exact same input. So for me, I put 4, 2, 1, 3.95, and the same input 931, etc. 6481. But still, I got minus 0.006.
Wait, I'm gonna try again.
Right, yeah. Try to check. Now for Muhammad Faris, 0.009. 0.009. Let me check very quickly. For the values of 10. Because in that case, it's either you activated the mode or my calculator is giving something else. So let me check. So we have 4, 2, 1, 3, 1, 3.89. That's this code is 100. Okay. With 10 and 1. And you get 3.3. So our results. Yes, okay. For X, you get minus 0. For A2, sort of. You get minus 0.003. Okay, you use 8. Okay, interesting. So let me just come back to it. So 64. And then 8, 1, 3.41. No, I still get 0, minus 0.06. Yeah, the A2 is negative, but it's minus 0.006. So check again your input. You should be able to go to equation, not matrix. I don't know if you guys are using matrix.
Yeah, I'm using matrix.
Oh, that's the problem. Go for equation, guys. Go for equation. You're using Casio FX991ES, right?
Yes.
Okay. Go to equation and no, go to mode setup and type equation. And for equation, you type there's 1, 2, 3, and 4. 1 and 2 are simultaneous equation, are for simultaneous. Now you have a second degree simultaneous. So you type number 2. Type number 2 and you key in your values. So the first one is 4, second one is 2, third one is 1. And then equals to, it's not shown here, but D is what is equal to 3.89. Oh, sorry, 3.95. 95. Again, same goes for for the value of 3, as shown here. The value of 3 is 9, and you have 2, then you have 1. Goes to 3.89. Lastly, 64, 8, 1 equals to 3.41. So the value, the results cannot be, simultaneous equation, Muhammad Faris. Simultaneous equation. So if you have the calculator, the white and black one, you just type simultaneous equation. You have different degrees. You type the degree, the secondary degree, which is polynomial, and you will get the values.
Now I got the same value, 0.006.
Okay, perfect. Now, be very aware of that. Huh? Don't go to matrix. Sorry. Yeah, see, that's the other problem. So this is why it's good to practice, especially during the exam under pressure. You get different values. Everybody gets different values, so be very careful. And so they mentioned 4 significant numbers and stuff, but I don't think here they mentioned it. It's good. You don't need to worry about that. Okay. So lastly is A0 equals 4.034. So what you do now, now that you have the results A2, A1, and A0, which is pretty simple. So far, how is it? Simple or not?
Yeah, little simple, yeah.
Okay, supposed to be simple. Because it's polynomial, just get the values, get the unknowns, and you're good. You already have row X and row of X. So row of X now will be what? A2. A2 here is what? Minus 0.00, sorry, every time again. 0.06. It looks like a 6. 0.06. Okay? This one is X squared minus 0.03X plus 4.034. That's it. Now you have row of X. How easy it is to determine row of 4 and row of 6. Just like that, you get the values 1 and 2. And you're good. Question A has been answered or no? Okay, perfect. Now, question B is different. We go to another chapter. So once again, for curve fitting, supposed to be easy. Don't get it confused. Don't get it confused with the slides, because slides usually they some nonsense. Okay, be careful. The slides here, they mention that you're supposed to get the value, which is here. Okay, you're supposed to get the different values. Okay, that has already been put in the table, and then you put here the equation. You don't know yet what the equation looks like. You key in the values for different what's it called, X. For X equals 1, X equals X2, X1, X2, X3, X4. From there you get the unknowns, and from there you get the equation, and just key the value. Okay, and that's for how many? No matter the orders. Yeah, Mubarak. You have something to say?
Sa'id, can you like go to slide 9?
Slide 9. Let's go. Okay.
Because I'm trying to like understand more on slide 9. So if you look at the second column, from second column to fourth, I think it's understandable. But the first column, the 2564096, where did he get those values from?
Okay. So here you have X of 4, right? You have here, here, X. You have X, right?
Yeah.
And you have 1.
Okay. Okay.
Okay. So here, you already have the fact that you're supposed to multiply x by 4 to the power of 4. So 256. So let's check. Let me just check something. Let's check what is it. Is the power to the power of 4 of what? So square root.
I think I get it. He just took x and raised it to the power of 4.
Yeah. So 4 to the power of 4 is 256. 4
Okay.
to the power of 3 is 64. 4 to the power of 2 is 16. 4 again, same. The power of x is 4. And 4 to the power of 0 is 1. So this is what has already been shown here, basically, just before they show the equation. They show what they expect. This one. So the x is not unknown. You already have the x. And you already have f of x, which is y. What you have to find out is a3, a2, a1, and a0 to determine the final equation. Once you get the final equation, you need to have, depending on the number of unknowns, you need to have equally the same number of equations. So you cannot have 4 unknowns and only take 3 values and then you're good. You can find all the unknowns. No, you need to get the 4 values. But usually you don't have third order. You only have the second order. And not even lower. You don't have first order. You only have second order. So curve fitting, when they say, what's it called? What was the question here? For instance, the question, if we read it again, they say estimate the missing value using a numerical method with a second order approximation. So that one is curve fitting, 100%, because you are estimating values here, missing values. It's always this way. Or they give all the values and just ask you to derive the equation. That one is easier. You just derive the equation like we did here, and you stop here. Here you can stop. You don't need to get the values of 4 and 6. Understand? So that's what it mainly is about, curve fitting. And they never ask you specifically a method. It's just polynomial, just use matrix and you're good. Okay? Now, just to reduce the stress, if you check out, go ahead, Muhammad Faris. The question asked, yes, you need to, it's implicit. Sometimes it's complex question, sometimes it's direct, clear. When they ask you to determine the missing values, you determine it from what? You don't just guess. You need to have the equation, then you determine the missing values. If they just ask you to derive the value, it means determine the equation. You derive the function. It means determine the function. We have many ways. They have many ways of asking it, but it's always curve fitting. Question A is always curve fitting. And so, just to reduce the stress again, we go for least square regression. You just have some kind of the same concept, and if you want to apply it, you can. But really, they don't ask for it. Linear regression, for example, is too complex for no reason. For them, they don't ask it. However, let's take the example of this one, quadratic regression. That's what they might ask you. Okay, you have xi already. We know that you have yi, here xi here as well, right? So they just ask you to put it in the form here of matrix once again. Similarly, so for arranging the similar, for example, here they say expanding the equation. No, before that, you need to get the sum of xi to the power of 0. Xi is 1. Okay, hold on. For this one, oh, parabolic. Yeah, see, this one is not so direct. You need to compute it. So, which is why they don't ask it actually. In the least square rather than addition. Yeah, no, they don't ask it because you need to compute it, and the calculator most of the times is not enough, especially for this part specifically. So just be careful. They don't go for quadratic regression method. Is not there. However, it's more direct. So they might ask theoretical question only on regression. They might ask, for example, what is a more accurate method to use, you need to know about quadratic regression method. Okay, so this is in terms of theory. They will ask what are the different methods to determine a curve. So you have collocation polynomial, you have regression method, you have interpolation. Understand? Is it clear to everybody? You have three solutions. Interpolation, is there anybody who doesn't know? I think everyone knows interpolation. Okay, yes. So it's just the basic. Don't get confused again with the slides. Slides are once again very confusing. Don't get confused with it. So back to okay. Back to notepad. Bismillah. Question B. What does question B mention? Question B says, now that you know what the different values are here, determine the mass M here in kilogram using numerical method in a second order approximation. Okay, so for that you need to understand that when it comes to integral, you have this chapter. Send it in the group as well. Let me check it again. Send it in the group, numerical integration. Okay, you have three chapters: numerical differentiation, curve fitting, numerical differentiation, and numerical integration. Here you have an integral. Asked to find M, you need to get it. We'll check out soon, inshallah, in case of differentiation, what to do. So, oh, sorry, this is curve fitting also. Yeah, that is numerical integration. Okay. Huh? Integration. Okay. Now that's good. Okay. For numerical integration, you have also, I think, three methods. Let me check again. This is not numerical. Okay. You have three methods: Simpson's, trapezoidal, and Gauss quadratic. And in Simpson's, you have two methods. You have the 1/3 and 3/8. So we'll get into it soon, inshallah. Don't worry. The easiest is trapezoid rule. If they don't ask anything, you go for trapezoid rule. Understand? So what is it exactly? It mentions that for a single function that where you have what's it called, integral here. This integral fx, I equals to integral of fx. I equals integral of fx. If you really extend it to especially to xn, we will find out that it is equal, this integral is equals to 1/2 h. H is what? H is the interstep, the steps between, the steps, iteration steps. We'll get into it soon enough. For now, it's just theory. It's the integration step, iteration step, sorry. It's equals to f when x equals to 0, and f when x reaches the limit. X is usually between 0, sorry, what is it? What? So x is usually between 0 and n. Understand? So f when x equals to 0 and f when x equals to n plus the multiplication by 2 of all the f in between, all the results, function results in between. So a clear example of that is, for example, here you have rho, right? We know that rho is a function. You know that rho is a function, and rho has from 0 until 10. Okay? So I'll take this as 0 and 10 as n. Okay? So I'll say f of 0 is equals to what? 4. F of 10. F of n equals to 3.3. Right? So here, you mentioned that, okay, f of 0 is equals to, okay, f of 0 is equal to 4. F of n equals to 3.3. So here, 4 plus 3.3 plus 2 times 3.95 plus 3.989 plus 3 point whatever here, and 3 point plus 3.41 plus 3.10. This is the trapezoid rule, very direct. Okay. Now the thing is that for our m here, rho x is not fx. If you see, if you compare the two here, fx is really equals to rho x times acx. Is it true or not? Is everyone on the same page or not? Can you guys see what I'm seeing? Okay. Well, mashallah, Muhammad Faris is the active one right now. I don't know.
السلام عليكم يا سعيد.
وعليكم السلام ورحمة الله. Yes.
Just I want to ask, have you finished the differentiation, or this is the first differentiation and integration? This is the first part of it, or this is the second? Because I just entered the class.
Okay. No worries. For now, we haven't done differentiation because this question here only puts what's it called, curve fitting and integration. So you have here for question 1, they can put only curve fitting and integration, or curve fitting and differentiation, or all 3. For me, during my time, they put all 3. But for last semester, they were quite nice, so they put only 2. So hopefully they do the same for you also. Just differentiation this time and curve fitting. Hopefully not, the integration also. So they're pretty easy going when it comes to this. But you have to know all 3, at least. You have to know all 3. However, it's very direct. So I'm explaining right now the trapezoid rule. Understand?
Okay,
so
because the doctor give us like some tips. They told us just to do. They told us just they like very sure they're gonna bring the trapezoidal.
See, trapezoidal is for integration. See that?
Yes, this is what are coming in the test.
Yeah.
This is what the doctor said.
That's a good point. So now I'm going to focus fully on trapezoidal because that's what I used for my for my solution. However, I'm going to explain it first, very quickly. Okay. So for integration here, integration. Now we finish with question 1. Now it's question B. With A finished. Now B. Integration. You have 1 trapezoidal. So if they ask, always they ask about this question. Just now A is no. A is curve fitting only. So you need the just to get the values to find the unknowns. You have the values. They give you the table here, and so you just derive from these values the function. So you have x and you have f of x. So you just use whatever x, how many x you need for the number of unknowns here already put here. Okay. So you have to first set straight what does the equation look like. If they ask you second order, it means that it is polynomial. You need to put a2 x squared plus a1x plus a0 without even thinking. I think my camera has a problem somehow, but you need to put it without even thinking. Understand? Let me try to open it again. Okay, it's from the computer, from the phone. Just give me a second. Okay, that's okay. Okay, no problem. So automatically, it means automatically that you need to put a quadratic equation. If they ask third order, automatically third order equation. a3x cubed plus a2x squared plus a1x plus a0. So it's always this way. Just make sure you know what does your function end up look like. What does your function look like in the end? And from there, you determine how many unknowns you need to find. From there, you decide how many x and f of x you will take. So now again, back to trapezoidal. You have trapezoidal, you have Simpson's 1/3 And this will be depending on the number of x that you are given, basically, which one to use, Simpson and Simpson's 3/8. Okay, what this really means, we'll get into it soon. So number 3, and then lastly you have Gauss. Then Gauss something. Let me check. Okay, Gauss quadrature. So Gauss quadrature. Okay. So just to fast forward now, trapezoidal means that you have okay. Okay. Sorry, there's a problem here. See here? Okay, so it's here above. So trapezoidal means that you just take, you have I here, just like already shown, here. It's very difficult to adapt it to this. Okay. Okay. So just like we shown here, you have I and f of x. Okay. So our I here is m equals to a and b here. However, in the question, if you see clearly, it's 0 and L, a, b. Okay. The f of x now is our target. It's rho x times ac of x. Both are functions and both have their values here. Understand? Now, the most important part, once again, is that this m, let me come back fully here. Then that's this one. Then, okay, perfect. And then this m has f of x dx equals to 0 L rho x ac of x dx. Clear? Now they say that if you consider this to be f of x, whatever this is, okay, go ahead, Muhammad Faris. Muhammad Faris. Meeting tab. Okay, yeah, I'm trying to remove it actually. Okay, perfect. Okay, so now we have m equals 1 over 2 h. This h is iteration step. Okay, we'll get into it soon. Times f of 0 when x equals to 0 plus f of n when x is equals to L, which is the maximum here, okay? Plus 2 times f of, for example, 1 plus until just before f of n. So let's say before f of n, we have f of 6 when x equals to 6. Good. Understand? However, n here is not really this final number here. 10. No. N is this one. So how you count it is 0, 1, though here is 2, 2, 3, 4, and 5. And then you have n. So n here equals to 6. Very important. Astaghfirullah. F is not only this one. F is not only the iteration. So we'll look into it. So now you have, let's take an example. F of 0 equals how much? Can you what's it called? Out loud. F of 0 equals to what? Okay, 4, not only 4. Okay, we know that here we have 4, but it's row times AC. We already shown here. Okay, 4 times 100. So it is 4 times 100 because it is row 0 times A0. Careful. So very simple, just application. Straight application. Whatever this fx is, you determine the fx of all the numbers, or f of all the x's. So you have from x equals to 0 here until x equals to 10. Okay? X equals to 0 until x equals to 10. You have to know that. You have to determine it. It's clearly stated. So this is what I put it here. This is what I put on the table here, as you can see in B. So I determine what is the f for each one. Okay, f of 0, I determine that it's 400. F of 1 is 406, etc., etc., etc. You just calculate it and put it here. Understand? As a table for you to be able to show your calculations. Done. Is it clear so far? Second order integration trapezoidal. Is it clear how you get to it? Okay, so the form is clear here.
I have just one question.
Hmm.
I mean, the question you're solving is question 1, part B.
Yes.
Or question 2, part B.
No,
Question 1, part B. So they are asking mass in kilograms using numerical method with a second order approximation. We take the equation we find from the part A, right?
No. We don't use the same equation because the what's it called? We don't need to express. We don't need to express the row. We just need to have f of x. Yeah, the value here, f of x.
The value of fx.
Fx, yes. So fx equals to a0 times AC. So
this is the equation, the equation of trapezoidal.
Yeah, the equation for the form of equation. Yes.
The form. Just let me check on the slides. This is the rectangular rule, and this is trapezoidal. Okay.
Yeah.
The uniform I equal to 1 over 2h fx1 plus fx2. This is the form.
Not fx1 plus fx2. 1 over 2h times f0 plus 2 times f of all the x in between. F1 here. Let me just. And F2, F3. Well, they didn't change much. Okay. And then F4, F5. This is in between, right? Between.
Yes.
Okay, between 0 and 6.
Between 0 and 6, we have 1, 2, 3, 4, 5.
Okay, so this is what you put here. F of 1, 2, 3, which is here. You already put x here. You calculate f of x and use this f of x. Okay? When x equals 2, and x equals 3, x equals 4, x equals 6, x equals 8. Now the extremity, the first and the last one, you exclude it. F of 0 and f of n excluded completely. You understand?
Excluded from the summing.
Yeah. No, from the multiplication. Yes.
Okay, so I put like f of 0 plus yes, f of 0 and then plus open a bracket, and between 0 and 6 I do multiplication, the values.
Yes. Yes.
and then close the bracket and plus the final value.
So here, when you say multiplication of the values, you multiply the values by 2. You don't multiply 406 times 412 and etc. You plus, you add F1. Yeah, F1.
Okay, we add them all, but multiply with 2.
Yes, add them all, then multiply by
Okay.
2.
And after we have the value of the multiplication, we add f of 0 and f of 6, and then multiply with h over 2.
Yes, exactly. Now for the H here, now that we got, is it clear for everybody first? Now everybody understands or not? Don't hesitate to interrupt me if you don't understand, especially because I don't see it. Well,
Okay,
everything. How do you understand everything, Muhammad? Is there something you don't understand? Because now I'm moving on to H.
I have a question also on part 1. They ask estimate the missing value using numerical method with second order approximation. So we need to find the value, the equation first for the second order, and then do what they call it, the after the regression interpolation. Yes.
No regression, no interpolation. Be careful. Be smart. No integration, no interpolation. If the no regression, interpolation, if they don't ask, just go for what's it called, simultaneous equation, and you solve it. No need for regression. All of this. Just get the equation like this one. Get the polynomial equation. Define the x that you will use. Define the equations now. Row of 2 equals to equals. So this one also equals to this. This one also equals to this. Now that you have 3 equations, just do simultaneous equation on your calculator and get the values.
Okay, I see. So
you get the values.
Okay, I have another question. How do we put the values in this matrix? Because I don't know how to. I know how to do it without the matrix, but when I asked the doctor, when I asked the doctor, she told me if you do it without the matrix, we are gonna penalize you because the matrix is like a critical part of the solution. So we need to do it. Yes. So that we need to put. She said at least put the matrix and do the calculation by the calculator. It's okay. But the main thing is put the matrix.
Okay. So you're contradicting my point actually. So luckily you said it, because I was saying that the matrix is not really necessary, whatever. But now I believe that depending on the lecturer. So be aware, guys. Make sure that you put the matrix. So for the matrix, for basically what I did here is I put A2. I substitute the x. Here is row of x equals to something. Okay, so x here is 2. Understand?
Okay, when x is 2, it's gonna be 3.95.
Oh yeah, exactly. When x is 2, it's gonna be, how do you know?
We just substitute the x and the equation we got, the final equation.
No, but how do you know that row of 2 equals to 3.95? How do you know?
Because after we do the equation, we need just to substitute the values of x. Because here we have x equal to, when x equal to p should be 3.95. Like it's about making sure our function is correct and give the correct answers.
Okay.
So
basically, you're right in some way, but I believe that I don't understand exactly what you're saying. But what I'm saying here is that how do you know here that row of 2 is equal to 3.95? It's because it's provided. You don't need to look for it.
Yes, it's provided. Yes.
Yeah. So they give you the x and they give you f of x. Always give the table. They give a table. So you should know who is x and who is f of x. Sometimes they don't put x, they might just put t and v and stuff like that. So you need to know which is x and which is rho, which is f of x.
So we need the first thing we need to know the independent and dependent variable, right?
Yes.
The independent variable is x, and the dependent variable is p.
Rho,
P and AC.
Perfect.
Yes.
Perfect. Now you understand. I think you understood from the beginning, mashallah. Okay. So-
Yes, because I attended this class with the doctor, so that's why
Ah.
somehow I understand.
Allah yabarik, Allah yabarik. This is what I'm saying. So here you have the equation, for example, rho of 2. You have the equation of a2 power 4, because here is x squared, right? 2 to the power of x squared and 2 to the power of square equals to 4. Right or wrong?
Yes. Yes.
Okay. So here a1 times what? X or x squared?
A1 or you mean A2?
A1 here. A1.
A1. A1 x1.
Okay. So x is what here? Which value
X
do you?
the value of 4.
Are you sure?
2.
Rho of 2.
Yes.
Exactly. So 2.
Yes, it's 2.
Yeah, 2. Because we say rho of 2. Rho of x. Rho of x. So you have a2 times x squared. a2 times 2 squared. Let me just.
Oh, you mean this is P? I mean, I thought in the brackets it's 2. It's 4, not 2. That's why.
Oh, no, sorry.
No, it's okay. I understand. Okay, this is 2.
Okay.
This is because it's 2 square. 2
Yes.
square is gonna be 4, and the
Exactly.
other one is gonna be 2.
Okay. Equals to?
Equals
Okay.
to should be 3. Much? It is for 4. You do it by calculation by calculator. You have to find the answer.
No. Before calculator. Okay. Now we are you want to know how to convert it into matrix, right?
Yes, I want to how to convert the values before I got the value of A1, A2, and A0.
Okay, perfect.
How-
So
how
now
to
we
get
have
it.
here the first. So now we have here the first equation, right? Equation
Okay.
number 1. Okay.
Okay, it's gonna be the equation number 1. It's gonna be Px equal to A2x squared plus A1x plus A0, right?
Yes, but x
Okay.
you replace it by the first value.
The value. Okay.
Okay. So here, how do you convert it into matrix? This first equation. It will be this will represent the first line. Okay.
Okay.
This will represent the first line. The unknowns for sure. It's here. Okay. Unknowns
Okay.
for sure. You only put the knowns. Sorry. You only put the knowns in these types of brackets. Unknowns, put them in this bracket. Okay. So
Okay.
the unknowns, as you see the order A2, A1, A0, you put it vertically A2, A1, A0. Okay.
Okay.
Now you have 4, 2, and this is what? 1 times A0. Okay.
Okay.
It's already marked. Let me see. My phone didn't. Exactly.
Okay. This is Maghrib and 6 minutes ago.
Oh, subhanallah. Yalla, guys. Now we take a break. No problem. Huh?
Can we just finish this part because very fast.
Allah, well, I'm walking to the mosque, so it's
It's okay. It's okay. Okay.
no problem, guys. Huh? We meet inshallah 9:30, 9:40. Sorry, 7:40. Yeah, 7:40.
So okay. Inshallah.
عليكم السلام ورحمة الله وبركاته.
Can we just go for the matrix because you already explained it to the rest of the students. Just
No problem. No
really
problem.
quick. Okay.
And if you are still confused about it, you can check out YouTube videos about it. Inshallah. Okay.
Okay. No, I'm not very confused, but I just need the order. but it's okay يعني I think إن شاء الله I'll get it.
No problem, no problem. No, there's no pressure actually, and I really hope for test 2 you guys all get it right. Because it's very simple, okay?
إن شاء الله.
So just a quick recap. The fact that for question 1, okay, I need to turn it on. Yeah. Fact that for question 1A, all we did was define the quadratic equation. That's the first step. Second level, choose 3 known x and f of x. Okay. Step 3, derive 3 simultaneous equation. Okay. And then step 4, determine A2, A1, and A0. Step 5, substitute into f of x. Lastly, determine f of 4 and f of 6 using the equation. Okay, is it clear to everybody? That's all we did.
Yes,
Okay.
it's clear.
Now for B, what you first need to do is determine which method to use. We decided trapezoidal, okay? Trapezoid rule.
Said, I have a question. So in the second part, can I use trapezoidal for every question I got?
Sorry?
I mean the first question, part B. Can I use a specific method to the all the questions I'm gonna solve? Or sometimes it works, sometimes it doesn't work.
For part A, can you use what?
For question A, for question 1, part B.
Part B.
I can use just a specific method. I learn it, I understand it well, and use it for every question I got.
Yes, you can if they don't specify. If all of a sudden they say Simpson, then you need to choose Simpson. Okay?
Okay.
You are going to study the trapezoid rule only now, right? We will go in depth with the trapezoidal rule, and then I will show you how the Simpson works after we understand the trapezoid, because it's easy to understand from the trapezoid how they got to the Simpson. Understand? So we'll look also into the Simpson, just for accuracy. So back to the trapezoidal here. So what they ask in question B, once again, determine the mass m here in kilogram using numerical method with the second order approximation. So we determine for the trapezoid rule, method, that we need to put this integral in the forms of 1/2h f of 0 times f of 0 plus 2, all the f in between, add up plus fn. That one you have already determined. Okay? Now, we know what f of 0 is here. F of 1, f of 2, f of 3, we know all of them. However, h, we don't know yet. So for h, it says that h equals x of n minus x of 0. What is n here? X number 6. x0 is here. So x number 6 equals to what? X of n equals to 10. Okay? X of n. Minus x of 0 is here 0. So x 0. Okay? Over n. N is not the number of x 1, 2, 3, 4, 5, 6, 7. No. You start from 0 here, the count, which is number 6, which is 6 here. So you put 10 minus 0 over 6. You get this value. Is it easy to understand or not? H value. Is it clear? Okay.
Again, please. Because the internet was lost.
Okay. I'm saying that H here is x of n here. And x of n, you count it this way. N is from 0 to 10. 0, 1, 2, 3, 4, 5, n. Okay? And you see the count.
Yes. xn, okay.
Here. 0, 1, 2, 3, 4, 5, and n. Not x here. So n, we have how many x values?
Okay.
We have x values from 0 to 10, right or no?
Yes. But it's 6 values. So n is equal to 6.
It's 7 values. But
Or
here,
6 values.
n starts from 0. So from 0, 1, 2, 3, 4, 5, 6. Understand?
Okay.
So n equals to
N should equal to 1 to 0. So it's going to be 7.
okay. It's going to be 7 if you start by 1 here. If the number here you start at x1. But here we don't say x1. It's x0. So x0, x1, x1, x2, x3, x4, x5, and x6.
6.
Understand? Because it
Okay.
starts from x0, not x1. So n equals to 6.
Okay.
Clear? Okay. So here, what I did was use n. We know that n equals to 6, we put here. And xn, we know that it is the same one as in the table here. X of 6 equals to how much? Call it.
Again, x plus what?
X of x6. X6.
X6 is going to be 10.
Okay. X of 6 equals 10. So I put here 10 minus 0 over n.
Okay.
Understand?
Okay. Over n.
So
Okay.
n equals to 6, already determined, right? x6. x0 to
It's
x6.
going to be 10 minus 0 over 6. Okay, it's going to be 1.667.
Perfect. So
Okay.
this is what I will put back as a value here. 1 over 2h. Okay?
Okay.
So if you put that as a value, you get m equals to 1.667 over 2 factor of 400 plus 2 times 406, I believe, 6 point something, plus until the before that. Here.
Before final value. Before
Yeah, before final value. 453.53, right?
Yes.
So 4, 53. 53.53. Okay, then you close the bracket, plus 495. Okay,
Okay.
now you have your bracket here, most important bracket. Okay, so here this is f of 0, this is f of x equal to 10.
But,
Okay,
I have a question, Said.
I know.
From where I can get the values of the 400, the
Okay,
106, 4543? Because the first equation, or the equation we determine in part A, it is for the P. For the P, it's not about for the
yes.
mass. So how?
Okay. Okay. So here basically you need to have the same form as I equals to 0 to n fx, right? Dx. So if they tell you that you have here instead of fx you have rho times ac, then
Yes.
fx equals to how much? Equals to what?
Equals to a multiplication of the values of
Rho.
rho,
Yes.
rho x0 multiplied by rho x0 for P and AC.
Okay, it's not x0, rho x only. Rho x times ax. Okay?
Rho x, okay, rho x
So
multiplied
it's not fixed value. Here we know that rho, for example, f of 0 equals to rho of 4 times a of rho of 0 times a of 0 equals to 4 times 100. Okay?
Okay, this is from where we got the 400. So
Yeah.
no need to substitute in the okay in the equation we got. Just multiply.
Yeah, no need to substitute. For me, I just multiplied it and put the values here. 400,
Okay.
406, 412, etc. So I have all the values now. We have x here and f of x. I calculated the f of x here after multiplying them together. Rho and a. Understand?
Okay, makes sense. Okay.
Okay. So after that, we get the final value of m equals to 4,295 kilogram. Okay? Kilogram because they specify that it has to be kilogram, but rho, we already know that rho equals m cubed per kilogram. Or kilo, yeah, m cubed per kilogram, and a equals meter square, or kilogram per meter cube, I believe. Rho equals to kilogram per meter cube. Gram per centimeter. Yes, okay. So gram per centimeter cube, and here you have centimeter square. So here you have. Okay. Let me shed the light on it. So we have gram per meter cube times centimeter cube, sorry, times centimeter square. Okay. So centimeter cube, centimeter square, and f of x, if you multiply those two together, you have gram per centimeter. Okay. Now the h is what? Is x. X is what? Centimeter.
X is in meter.
Yes, in meter, sorry. Okay. So you have whatever the value here, gram and centimeter. Gram, you need to time it by what? Times 10 to the power of 3 to get kilogram. Over
Yes.
centimeter times 10 to the power of 2 to get minus 3, sorry. Minus 3, yes, minus 3 and minus 2. From gram to kilogram, you need to times it by 10 to the power of minus 3. From centimeter to meter, you need to times it by 10 to the power of minus 2. Okay? Clear?
Okay.
Okay. Then you multiply it by h, which is in meter. Because you have meter over, you have meter over meter, is it?
H is, I think it's without.
Yeah, h is without, because you have meter minus.
Meter over meter.
No. No, it's over a number. It's over a number. So we have it's still meter.
Oh, we still have meter.
Because here is 10 minus 0 over n only, not over x. So it's still centimeter. So you get in kilogram. So whatever the value of h is here is still, what's it called? You multiply by 10 to the power of minus 3 minus 2, 10 to the power of minus 3 over 10 to the power of minus 2 equal what?
So, Said, if we substitute the values and to find the final value is gonna be gram per centimeter, and then we need to transfer it to kilogram.
For this one, yes. Then if you transfer it into kilogram, you get.
So we need to multiply it again by h.
Yes, no. You don't need to multiply again by h. You need to multiply by 0.1 because here you will get 0.1 kilogram per. It's really 0.1 kilogram per meter because this times it's to get kilogram per meter because it's 10 to the power of minus 3 over 10 to the power of minus 2. You guys remember, right? Understand or not?
Yes. The unit.
Let me show it here. Okay. So here, kilogram per centimeter cube times centimeter square equals to gram per centimeter times 10 to the power of minus 3 over 10 to the power of minus 2 equals to kilogram per meter. Okay? That equals to 0.1 kilogram per meter. Understand?
Okay.
10 to the power of minus 3. 10 to the power of minus 2 equals to 0.1. So the value that you get, you multiply by m, which is meter, which is h, equals to 0.1 kilogram. This is in terms of unit, not in terms of value. 0.1 kilogram. Okay, whatever the value you get. So here, if we get, what is the answer? Okay, if we get m equals to 4,000, it's not in kilogram actually. It's in, what is before kilogram? I already forget. So it's basically, if you convert into kilogram,
It's gonna be before it's gonna be gram per centimeter. If you multiply this one.
No. You multiply it by 0.1 only. 0.1 kilogram. 0.1. Yeah, 0.1. So it will be 4 to 9.5 kilogram. Actually, yeah. Thanks for bringing this to attention. Is it clear for everybody? How I calculated the unit, the final unit? This one, whatever value you get, you need to multiply by 0.1 because of the conversion. Okay, perfect. So now we move to C. C is pretty simple. Hold on, I'm going directly to the answer. What is? Okay, C. How can you increase the estimation of your numerical methods? Now you guys have to let me know. For A, how can you increase the estimation of your numerical methods? There's two solutions because we know that there are multiple methods and one is more accurate than the other one. Okay, so what method is more? This is how you increase the estimation. Okay, first of all, for C, yes, the first.
I think we need to increase the order of the equation.
The order of the equation, yes, exactly. If you get a third order, you can get, okay, by increasing the order of the equation of the characteristic equation, basically, the equation. Okay? Second of all, what is the other one? For A, we are still talking about curve fitting, okay? What is the other solution?
Maybe take more samples, or just not stop in x equal to 10 meter.
No.
To 20 or-
Think about it deeply. Basically, it's actually it's simpler than taking samples. Basically, if you have this one, okay, you only have this value here and this value here. I'll ask you to calculate this one, okay? And this one depends on each other, okay? So you are supposed to find the middle for this one. No, this is too easy. Okay, let's say that you have this one. If you take this point and you calculate the middle, okay, based on this value and this value, if you calculate the middle, you get this value. It is more accurate than if you take more, if you decrease the increment. Basically, this was x equals to 1, this was x equals to 2, okay? You're supposed to find x equals to 1.5, for example, okay? Now you change it. Now you're going for x equals to, first of all, these two values, okay? You're supposed to find still x equals to 1.5, okay? However, you decide to come closer. Get these values first, and then in between you find this value. Are you gonna get a more accurate value than this one? Which one is more accurate, 1 or 2? If you come closer, now I came closer, I get the value. I already have the value of 1.75, astaghfirullah, 25, and 1.75 here, okay? Can I get the, okay, exactly, number 2, because we are closer, the bracket is smaller, is more microscopic view, okay? So the other method is to decrease the increment. These two. Understand? There is the third one though. There is the third one. What do you believe is the last one? What other method can we use to determine to get a more accurate answer? You guys remember or not? We have polynomial, okay? Wally talked about a method as soon as he entered. So which method is that one?
I mean, what about it, Sa'id? The first one? The first method we talk about.
Yeah. In curve fitting, is there a method more accurate than the one we use, which is just matrix, which is colloquium, I believe. I forgot already the name. Collocation, yes. Collocation polynomial. Is there a more accurate method than collocation polynomial? Here. Is there a more accurate method? Alright, guys. Which method is the most accurate here? 1, 2, or 3?
In this,
Is there more accurate than 1?
I think the least square regression.
Okay, exactly. So another way to get a more accurate equation is by using the regression method. Clear, guys? Is it clear for everybody?
Yeah, it's clear.
Yes, clear.
So this is theoretical. This is why you need to be aware of the other methods, but you're not going to use them at all. Usually for question 1, the curve fitting is just simple simultaneous equations. So for C, this is for A, okay? This is for A, the curve. The second one, you have what? Integral. Yeah, go ahead, Muhammad Faris. So theory, just remember yes, exactly, perfect, you nailed it. And be aware of also of the most accurate one. So sometimes they ask you, is there more accurate? If you're already using the most accurate, you don't need to, especially for question 3, you will understand. So for the integration, numerical integration, is there more accurate than trapezoidal? More accurate than trapezoidal? Is there more accurate? Can we use a more accurate method than trapezoidal? Now, what do you think?
I think yes, we have something better than trapezoidal, which is the composite Simpson, I think. Well,
yes, exactly, Simpson. Perfect. This one or this one? We can use any. They are all both more accurate. Understand? So Simpson method, okay?
yes, it's clear.
Okay. And then also what else?
We have Simpson, composite Simpson. This is
Okay.
two, like.
Yes. However, why exactly we use the first 1/3 rule? If you put 3/8, they might not give you the mark. Why exactly? This is what I wanted to show you very quickly. So this is why we'll go briefly into the Simpson. So the Simpson is a bit as simple, kind of as simple as the trapezoid. Now that you understand F1, F2, F3, F0, all this, it's kind of as simple as this one, as the trapezoid. So what Simpson 1/3 rule says, it says that for quadratic equation, you must have a number n that is what's it called? And 2, 4. I forgot how do we say it in English? Let me just verify it again. Yes, even number. N has to be an even number. This one. N has to be an even number. Here, our n is which value? What is the value of our n? 6, right? Right or wrong?
You mean what?
What?
The value of I.
For Simpson 1/3 rule, it says that if you want to use Simpson 1/3 rule, okay, the number of n, your number n, meaning the number of x value provided, has to be an even number. N here has to be an even number. X0, x1, x2. If you have 11 x, if you have up to x11, you cannot use Simpson 1/3 rule. Understand that? Cannot use that. If you have x10 or other even numbers, you can use Simpson's 1/3 rule. What does it say? It's pretty clear and straightforward. Let me just get to another page. Okay. So it says Simpson. Simpson 1/3. 1/3. It says that if I have the other one, yes, okay. If you have even numbers, then this integral that you have x I equals to 0 to n fx dx, okay, whatever the number is, okay, whatever the number is, you have I equals to 1/3h. H is the same as the one in the trapezoidal, okay? H equals to xn minus x0 over n, sorry. Okay? This h, factor of f0 also, plus 4 factor of all the numbers. Okay, I don't think this is a space. Let me just come closer a bit and erase. Okay, f of all the numbers where this n here, the n, the I or I is equals to 1 or 3 or 5 or uneven numbers. So for here, for example, we'll have the example of f1. Let's say that we remove that one. f1 plus f3 plus f5, and in our example it stops at f5, if you remember carefully. So f5, right? Stop, full stop, plus 2, sorry, yeah, 2 factor of, let me just, plus 2 factor of f2, because we have f0 is already here. You don't use it again. f2 plus f4 plus which f6? No. So nothing until the end. So in our case, we don't have anything after that. f6 is the last one, so it will be plus. It's not involved in the 2. Plus f6 here, which is n. Is it clear to everybody? Is it easy or no? How difficult is it? So you have I. Why we call it 1/3 is because here we multiply by 1/3. Hopefully you don't misunderstand it. It's not 7, it's 1. So you multiply I by 1/3. That's the only reason. That's the only difference. And you use it just the same way. Understand? No, so no need to be afraid of the Simpson 1/3 rule. It's simple practice. What you need to be aware of is the values of f1, f3, f5. Don't get it confused. For our case, we have two functions, rho x and acx. So don't get it confused. Don't mix the two. First, calculate f of each x, and then you can use the equations, just for you not to be able to misunderstand it. So determine which method to use. Oh, sorry, I don't know what. Okay, 1, 2. Determine. If it's already given, good for you. But if it's not given, determine f of x's. Okay? And then, number 3, apply the equation. Apply the formula. So, once you apply the formula, you simply have to be aware of the units, but everything becomes clear from there onwards. Understand? Just be careful regarding the units. Simple as that. Okay? Now, this is in the case where you have n equals to 6 or even numbers. Even numbers. Okay? However, in the case where you have n equals to 11 or n equals to whatever else, you use this one, this formula. Why? Because it's more accurate. Hopefully everything is clear. Okay. Why? Because it's more accurate. Okay. Simpson's 3/8 rule aims to further improve the approximation by fitting a third-order polynomial cubic equation. So you understand the idea of it. A3x cubed, A2x squared, A1x, etc. Understand? That's the hypothesis. That's the ideology. Okay, but you don't actually have a cubic what's it called equation. You have a what's it called a integration. So that's just the idea of it, and you just apply the same formula. Not in what's it called? Not the same as 1/3. You need to be a bit more careful, but this is the idea. So you have 3/8 h, okay, times okay, 3/8 h times f0, 3 times I, 1, 4, 7. What do you believe is between them? 1, you add 2 more, sorry, 3 more, you have 4, add 3 more, you have 7, etc., etc. So between them there is 3. There is 2 numbers between them. Between 1 and 4 there is 2 and 3, so 2 numbers between them only. Okay, the same goes for this one. You have 3 Yeah. So F2 will be left out. But that's the idea of it. You don't need F2 in that case. Just proceed directly to F3, F6, F9, etc., etc. Then you have Fn here and there. So for us, in our case, we only have F0, whatever, F1, F4, and that's it. You don't have F7. And then if you multiply by the other ones, you have, if you multiply 2 by any other number similar to I here, you have F3. So 2 times F3, and then you're done with it, plus F6. Done. Understand the idea? That one you can use long as the n equals to 3 times, well, I don't know how to, m, for example. Okay, a multiple of 3. So 12, etc. I don't need to explain it, hopefully. Okay, that's another idea of it. So trapezoidal again is the most direct, straightforward question, the straightforward method. If you have, yeah, go ahead, Muhammad Faris. Both f is different from 3 of 3 is difference of 3. F is difference of 3. Yes. Perfect. Now you understand. And one is multiplied by 2, the other one is multiplied by 3. But really it's with respect to which number? 0. For here is with respect to 0. For here is with respect to 1. So 0 has already been used here. So you have directly plus 3, plus 6, etc. And 1 is used here, not used before. 1 plus 4 plus, etc. 1 plus 3 equal 4 plus 3 equals 7. Understand? This is with respect to 0 and 1. That's the idea. So yeah, it starts with 3, it starts with 1. That's easier to memorize. Understand? So apply whichever formula, but you need to have the values of f here. You need it. Make sure you get the values of x first. Understand? Alas. Is it clear for question 1, everybody? How we did it? You can check here the methodology basically later.
Yeah, alhamdulillah, it's good now.
Okay. So I don't think I sent the what's it called, the paper that I'm studying. Did you prefer me to send? You prefer that I send it, or I can continue explaining from here? Is it okay? Well, yes is not the answer. Let me see. I'll try to send it. Bismillah. Okay. Okay. So now, question 2. Question 2, we go to the next chapter. We're done with we're done with the curve fitting. We haven't touched yet on numerical differentiation. However, we've seen the methods for numerical integration. Okay, Gauss, you don't need to look into it, since your friend already mentioned that it's trapezoid that is coming. So, but you need to be aware of it for the theoretical part here. Gauss quadrature, to improve the accuracy, basically. To just make sure you are aware of the values of the methods, basically. Halas. Question 2, I think I will need to bring this again back now. So let me try to make a copy of it. Duplicate. Okay. Halas. However, we'll remove all this. Okay. Oh, what time is it? Curry time is when? Is it curry time soon? Because my phone is dead right now. Isha 8:30. Oh, خلاص 8:30 already. خلاص, yeah, guys. We take a break now. Inshallah. Don't worry, the question 2 and question 3 are simple. once again, as simple as question one. Don't worry. I love this. So we take a break. This time I'll give until 9 p.m. inshallah, since people gotta eat and pray. So we take a break until 9 p.m. Is that okay for everybody? In the meantime, if you already ready, as you can check out the the sample I sent in the group, the solution basically. يلا we meet each other soon. السلام عليكم ورحمة الله. السلام عليكم ورحمة الله everyone. I believe everyone came back already. So we'll start in 2 minutes, inshallah. In the meantime, you may read question number 2. I don't know if you can read it from here. This will be enough to understand. Okay. So we go for the next lesson, which is IBP. Second last. IBP, initial value problem. Okay. What does this insinuate? It insinuates that for a case f of x, or a function f of x, we are only given the condition at the beginning, initial value. So an equation is called IVP if the values of the dependent variables or their derivatives are known at the initial value of the independent variable. So in other words, to make it simpler, like I said, you have x, you have f of okay, you have f of x at f of x at x equals to 0, or the dy, for example, over dx at x equals to 0. Understand? So these are the initial conditions, either the function itself or its derivative. Hopefully it's clear. Understand? So that's the most important part that you need to understand. Now, why I'm going to talk about BVP, which is boundary value problem, is because sometimes they ask you to determine which case is it, IVP or BVP. So BVP is when you know x at the beginning and x at the end. Sorry, when you know f of x 0 and when you know f of xn, or the derivatives as well. The same goes for the derivative f prime, and f prime. Okay. So that's the most basic difference between IVP and BVP. Is it clear to everyone so far? You only have the initial condition for IVP, and you have both the initial and final condition for BVP. Usually, BVP is in question 3. Sometimes they still want to trick you, so they will put it at question 2, and they won't say whether it's initial value or boundary value. They will ask you to determine whether it's initial value or whether it's BVP. Understand? That's the basic difference. Now, initial value has 3 ways of solving it. It's not this one, Newton's law or whatever. These are examples of cases where you use the initial value problem for certain specific differential equations. Understand? Mostly it's for differential equation. Haven't seen it being used for anything else. I think you learned it also in differential equation the way they solved it. The most basic form it comes in as is this one: dv over dt equals g minus c over m v. Well, that's the most basic form. That's the case, basically. That's the most basic case that they bring. So it can come as, for example, dv over dt equals to, for example, a times t minus c over, this is not at, a times t. Okay, let me just make it clear. Okay, A times T. Okay, make sure you understand that. Oh. Times T minus Cm over C over M times V. For example, so it can both come in terms of only V here on the other side, or both T and V are expressed here. Understand? So the unknown, what we are really trying to find usually is V, the function here, EV. That's usually the unknown that we need to understand. Fine. So don't worry. IVP is very, very, very simple. Okay? What you go ahead. Muhammad Faris. Okay. Muhammad Faris, yes, go ahead. Why is it A times D and not G? No. This is just an example, very basic example. What I mean by this is that it's not only, for example, let's say G of X is not only dg over dx equals to dg equals to ag plus b. For example, it can also be equals to ag plus bx plus c. So in this case, how easy is it to solve this equation? It's very difficult because you have both g and x on the other side, and this is the derivative of g. So this is why we resort to numerical equations and numerical methods, because this equation is not solvable manually, basically. Is it clear? It's just an example. Mohammed, is it clear? So you're confused. Okay, no problem. Okay, no problem. We'll get into it. It's explain, inshallah, for you to understand. Okay, so for this case, for example, you have dx over dt. This is for second order, depending on which order. Usually for IVP, they give first order. Usually, for the sake of the equation. However, sometimes it's second order, and you need to translate it into first order also. So the method. Let me jump right to the method. Yes, you have these two, Euler method and Runge-Kutta method. Runge-Kutta never really comes because of how complex it is and how time-consuming it is. So we are more or less going to focus on Euler's method, which is very simple as well. For Euler's method, it says something clear. This is just the how they came about the equation. So don't really mind it too much. But what it states is that y of I plus 1 equals to yi plus hf of x y I. What does that really mean? You can see, what's his name? Muhammad Faris here. dy, this is a function, for example. Use the Euler's method to solve the following. dy over dx equals to 4e to the power of 0.8x minus 0.5y, right? Do you have x and y on the same side here as unknowns? Y here and x. Can you see them? Okay, so this is what I'm talking about. Sometimes you have dy over dx, and you don't only have y as the unknown, well, as the expressed value here. And this is just to show you how much we cannot solve this manually. There's absolutely no chance for you to be able to solve it manually so simply, because you have x on this side and y on this side, and you have the derivative dy over dx. How do you go about it? Just integrate it and continue? No, because x is here. So it's actually very, very confusing. So what I meant here is that you might have the two unknowns, two variables, the dependent variable and the independent variable on the same side here, x and y. That's what I meant. Okay, clear? Clear or no?
Clear.
Okay, so basically the first equation was just an example and not a method. No, it was not a method, just a clear example. And so this dy over dx is what they call in here, let me change color, f of x and y. Because this has both x and y as factors, as dependent variables, as independent variables. Yeah, it depends on x and y. Understand? So this f here is not the integration of dy over dx. Not get it confused. And this is for even for range kuta. Likewise, that's the same. So this f here, f xy and yi, xi and yi is this one, the derivative of dy over dx, or whatever derivative they will give you. Understand? So here, in order for you to find y, for example, we are talking about initial boundary condition, right? So here they give x equals 0 and to x equals 4, they say that at x equals 0, y equals 2. So you have y0 equals to a number, right? 2, right? So here, what it will state is that y of 1 equals to, as you can see, equals to y0, which is y1 equals 0 plus 1, equals to y0 plus h, the value of x, f of x, I, and yi. So here, for example, the value is of I, yeah? Be careful of that. We are considering y1 as yi plus 1, and 0 is I, okay? So when they talk about here xi, they mean x0, and y of 0. So here it will be 4 e 0.8, sorry, 0.8 x0 minus 0.5 y of 0. Is it clear to everybody? Simple as this. This is the method. You just copy paste. You can see it here. Understand? This is Euler's method. So this specifically can change. This can vary. This one, sorry. Okay, this one specifically can vary. Okay, but this essentially is the same. Essentially is the same. So now that you understand how the Euler's method works, we now go back to the what's it called, notes, and you can see a very a huge similarity basically. So first of all, they mentioned that the m equals to 68.1, and drag is equals to 0.25. Gravity here equals to 9.81. Clear? They give you the initial boundary condition. How do I know this? They say A, if given the upward force where v is the velocity at the initial equals to 0, and the forces acting on the jumper is given as this formula, sketch the timeline and declare the specific conditions to solve this problem. So in terms of timeline, what they mean is that what happens from 0 to the end, basically. So what I did here in my answer, first of all, in terms of timeline, in terms of what's it called? In terms of boundary condition, first I said that at t0, in terms of time, v equals to 0 at the instant 0. So for timeline, we say that the jumper starts at an altitude of 50 meters high, right? Altitude. It's not altitude. And at that moment, v equals 0 and t equals 0. Okay. Now jumper has to stop at L lower than 50 because otherwise, subhanallah, we don't want to say what happens. And then the displacement will be considered as 50. So it's not L start from 50 and go to, no, L is the displacement. We consider it this way, it's displacement. And so at that moment where it's kind of stopped, just a bit before it stops, the V is for sure higher than zero. Otherwise, he wouldn't fall. And then the t is the final time span, basically the timeline, the end. T final is higher than zero as well. And so I sketch it for you exactly, but you don't need to sketch it on the day. What they mean is basically explain, but you may sketch it as well. So we know that it's not linear. It's impossible for it to be linear. So it starts from zero, but it goes exponentially. Okay. In terms of time, from the zero to the moment where it just a bit before the velocity starts to decrease, goes, because this game basically I think it's an elastic. If from my understanding, this is an elastic that they have, and so this once they reach the maximum, and then at 50 or just a bit before, I think maybe 20 meters before, starts to come down. Starts to come down because it stopped completely the what's it called, the jump, and then he goes up and then he comes down again a bit. So the velocity reduces. However, during this time here, velocity increases highly, and for L lower or equal to 50, we show that this V will increase what's it called, exponentially. Not exactly exponentially, but quadratically, basically. So the condition for this case, because this is the question as well. They ask for the condition. Where is it? Yes. Declare the specific condition to solve this problem. You need to state clearly that we have an initial boundary condition. That's the most important part. Initial boundary condition. IB boundary problem. So it's the same case. Initial boundary condition or initial boundary problem. With V equals 0 when T equals 0. So if V equals 0, the derivative is also equals to 0. So we take this to our advantage here later. Okay? So that's the idea. The idea is to first state clearly that when the jumper starts to jump, well, I guess starts, he what's it called? He has a velocity of 0, and the derivative also is 0. And then when he reaches his peak just before the altitude of 0, he starts from 50, he drops down. Okay, so that's the idea here. Declare the boundary condition. Is it clear? Okay. So what are you confused about again? You don't know if we have an initial boundary or what exactly? Okay. Sketching part. The jumper starts from here. He goes then before reaching the ground, because this is the ground. Before reaching the ground, the elastic holds him. So he just goes this way again, then here, and then he becomes stable, and they detach him after that. So we are talking about here when he jumps here. The velocity is 0. I don't know how. Maybe he's just standing here, and then he just drops like this. Understand? So he jumps from an altitude of 50 meters. Understand? So here, velocity equals 0. But if he drops, how will the velocity here be? 0 also? Is it possible? Is it possible for the, exactly. So it's not possible. It has to have a value. But that value, we don't know it, right? We only know the value here. So we know value for V of X equals to 0. But we don't know the value for V X equals to N, meaning the X, meaning L, the distance, at distance L. X0 is the height. Here you have 0. Then he drops until 50. That's displacement, okay? So we consider that as displacement. So Vx equals to 0. But it's not really the distance, it's the time. So they count After 5 seconds, where is he? Is he here? Okay. Is he here? Is he here? This is what they check. So it's easier for them to express it in time. Because V can also be expressed in displacement, as we have seen by differentiation. But here they express it in time. It's easier. So the X here is the time. So they say where V is the velocity at the initial is 0. So at the initial, what do you mean by initial? The initial time. The initial altitude is 50. So they cannot say that. They will say initial time. Understand? Is it clear to everyone? He drops at T0. T equals to 0, he drops. And then T equals to T final. T final. He arrives at his peak. The peak. Yeah, okay. He arrives at the peak, what's it called, velocity. We don't know what this is, which velocity this is. Do you guys get the idea or not? Still no. Okay. So for those who don't understand, let's go to example C here. They said determine the velocity of the jumper from 0 to 6 seconds. The time step of 2s, given the length is 30 here. So what they said is that he jumps from 0 here, and then they want to know, they mentioned explicitly that at t equals 6 seconds, he already passed 30 meters. Okay? So there's 20 more meters left, right? They don't care about that. They say at t equals 6, he's already traveled 30 meters. So what is the velocity at that point? So it's easier to express it in terms of t for them once again, because they put 0 to 6 seconds. And we know that at v0, t equals 0. We can also put at v0, L equals 0, and then v Hamilton means I don't know what. V, I don't know what, L equals 30 meter. You choose. But since here they mention specifically time step of 2 seconds, it's clear now what you should go with. What should you go for? If you already have the incremental time or distance, which one do you go with? Okay, so we've determined that first of all, right? But if you see there is a similarity, there's a similarity between this and this, and the equation given, just before. Where is it? At the beginning, at the very beginning. Yes. Can you spot the difference? Only the square here for V is the difference. Understand or not? So it has to be clear to you that this case here, we have an initial value problem, only because they only gave the value of V at the beginning. They say V is 0 when T is 0. V at the initial is 0. V0. V at T equals 0. Simple. So one thing here, I think they made a mistake. No, it's not here. It's for the next exercise. Okay, so here there's no mistake. Okay, no mistake, no missing, basically no missing info. So here they say using a numerical method determine the velocity of the jumper. How many numerical method is there for ODE IVP? Initial value problem. How many? I want to note it down. How many? The first one is what? What is the first one? What is the second one? If you follow. Yeah, but how, the what's it called? The numerical methods. I showed what are the different numerical methods. What are the different numerical methods used to solve this problem? IVP problem, initial value problem. Guys, Okay, the first one is Euler method. Perfect. You need to know this because later they might ask it. Explaining three methods by which you can increase your numerical session. Exactly, range quota. So you need to be aware of the methods. I think it's range quota. Okay. So these two methods. Now we will go with the Euler method, and here later we will determine how we can improve the accuracy. But here they didn't specify any method, right? So you just go with the easiest one, which is Euler. Euler, like I said, it states something very clear and very simple. Let's go to my answer. It states that for yi plus 1, for yi plus 1 equals to this yi plus h, what's it called, times the f. I'll remove this one. It was just for your understanding. So f prime xi yi. F prime is basically the derivative dv, but in the what's it called? In the methods, in the numerical methods, it's shown as f only. So don't get confused. So here, what xi and yi here, we have t and v. We don't have x and y. So we adapt it. Vi plus 1 equals to vi plus h f prime, what's it called? The ti vi. Now this h is different. There is h in numerical integration, which is equals to xn minus x0 over n. But this h here specifically is equals to step size only. Okay, nothing else. Step size. So you don't need to have xn minus x1. It's not a formula for this h. Be mindful of that as well. That's given by the formula, so we go by the formula. We follow the formula basically. Okay. So that's the first aspect of it. Now we know that they said that the step size is 2. So h value here will be what? Logically 2. So here I chose for t equals 0. I go one by one. Okay, guys, I go one by one. They said, what is the question? They said, using a numerical method, determine the velocity of the jumper from 0 to 6 seconds. They didn't say determine the function. No. We are not here to give a function. We're here to just get the values of 0 to 6 seconds with a time step. Understand? That's all we are here to do. So, for t equals 0, v equals 0 seconds. That's given, right? Done. For t equal 2, v2 equals to what? v2, which is I plus 1, equals to v0. v0. Let me come closer. Okay. Goes to v0. This is v0. Okay. Plus 2. What is 2? Is h, which is the step size, times g, which is 9.81. Okay. It's g here. Our function has already been given. Times g c over m. M has already been given as well. And I advise you to rewrite everything down just in case you don't forget, unless you will make a mistake rewriting it down. So as you prefer, basically, long as you don't make a silly mistakes in terms of inputting values. Times v at 0. V when t equals to 0. It's also 0 here. Understand? We don't have an expression of t here, the variable t. We only have v. Okay? So the value will be here. So you just key in. Is it clear to you guys? Is it clear or need further explanation for this one? How I got from t for t equals to 2s, t equals to 4s, or t equals to 6s. Is it clear to everybody? This is question 2 basically. This is question 2. So, like I said, it's really supposed to be easy. I really hope everyone gets a full mark for this one, because it's actually easy. You just need to get the values. yes. So if time step wasn't given, we would go for from. Well, usually they give time step. I have yet to see the fact that they didn't give. Let me check my paper right now of 23. Sorry, of semester 1, for example. If I check question 2, they said what? Choose appropriate, choose minimum steps. Okay, yeah. Yeah, sometimes also if they don't give. Yeah, so you're right. Here they said, for my paper, using the appropriate method, determine the deflection of the beam and choose the minimum step size. So yeah, go for the minimum, then 1, 2, 3, etc., etc. Go for it. You're right. But I think that due to the fact that you don't have any more, it's not open book anymore, maybe they will just give you the step size. I expect it to be a lot easier than when I was doing it. So don't get scared by my paper. This paper is the paper that I'm solving right now. With this one is from last semester, so it's more accurate. My paper was a bit more complicated. So if you are able to solve my paper, I believe that it will be very easy for you, inshallah. Okay. So back to the question here. Is it clear? Why did you out V0 as 0 and need 2 and not 2? Okay. V when t equals to 0 equals to how much? Okay. So when we say V of 2, here you can see, where is the pen? Yes. When you see here, Vi plus 1 equals to Vi, and then Vi here. Okay? So my Vi is V0. V0 equals to 0. So I put 0 here. Plus H, step size 2. Times the function dV over dt. My dV over dt, what is the function? It's clear here. Okay. So dV over dt, we use V0 here. Okay? So G is 9.81. Drag force is here, M is here. Now V is what? V0 equals to how much? Equals 0. So it has to be, this one has to be cancelled out because it's times 0. So we only have G. Is it clear for this one? This is why we have this value. Now, Walid.
I want just to ask in general, they always give the same applied thing for the question 2.
Oh no, actually no. Well, for us it was much more difficult in terms of what's it called, concept. But in the end it was all the same. It was all the same. But for example, us they brought some finite element concept with cantilever beam, distributed force, etc., etc. But here for last semester, I see it's just a game, which is why I really hope that you also find it easy. Is it clear or not?
Yes, clear. So, Said, are you going to share with us the solution that you are doing?
I already shared it actually. Let me see. I already shared it. So you can check it out in the group. Let me see. Yeah, it's the last message I sent. Huh? Just check it out.
Okay.
No problem. So this is the answer overall. Huh? So here for V4 you use V2. Yeah, V2. V1, sorry, V1. V1 is V for X for T equal to V1 here, which is 19.62. Put it here. Input. The same goes, huh? Everything stays the same. However, you change it. V1. Same goes for this one as well. V4. Oh, V2. Don't get it confused. V2. Okay. Understood? Shabab, is it clear? We can move on to the last question. Okay. Since it's not clear for such an easy concept, I will still wait for you to understand. So, Muhammad Faris, what do you not understand? State it clearly so that I can pinpoint it. I can do it in front of you, basically. How you not understanding how I got the solution or what? What exactly? The V2 is still don't get it. Why you put V equals 0 and not 2? For V2, okay. Just give me a second. Okay. So here you have V0 equals to V at T equals to 0 equals to 0. Is it question? Is it clear? I'm Mohammed Faris. Or is it, do we use calculated V from the period? Yes, exactly. Now you understand. V1 equals to V0 plus 2 factor of G plus CD over M V0. So the same V0 here, that's what we use here, is here and here. And so here the same goes, V2 equals to V1 plus 2 G plus CD over M V1, etc., etc. So that's just how it is. Simple as that. Okay, but the 2 here is H, the step size. So be aware of that and try to adapt as much as possible to your solution. Don't just go for any solution. So if we look at here the what's it called, this question, since we got a bit of time for this question, you see here y1 equals to y0, and here is f for x0 and y0. So here x0 is 0, x0, the first x is 0. They already gave it boundary condition at x0. Okay, at x0 y equals 2, right? So for x0 equals 0, for y0 equals to 2, and this comes from the same equation that they already what's it called, detailed here. The equation here is the derivative dy, derivative. Okay, this derivative, they decided to use x0. Oh, let's see. This one, x, no. Whatever. x0 and y0. Understand? Okay. So once this is done, this is considered the function that is here. So we are only following this function. So it should come as a differential equation, dy over dx. You express it as a differential equation. If they don't, mostly they will express it as a differential equation, and then you have this. Usually they will provide it. Well, usually, I don't know usually, but from what I've seen, the new type of test, they provide it basically, which I'm pretty surprised of. So, Bismillah. So to recap, no, hold on, we are not done yet. I'm searching the rush. Paris. It is the initial is mentioned in the IV. Yes, if only the initial. If the initial and the final is mentioned, it is BVP. The initial condition mentioned, yes. Initial and final condition are mentioned, is BVP. So be careful if the final condition is also mentioned or not. So for example, they say at T6 V equals to, for example, what was my result? They say 46.3. Usually when this happens, they won't give such an easy, what's it called, first order derivative. They won't give this, they will give something like this. What's it called? second order basically. So, but yeah, that's the idea basically. Initial value and boundary value. This is the difference. The only difference usually. And so the last question here: explain the three methods by which you can increase your numerical estimation. So we already defined that there is two numerical methods. So how? Three. So one, first one, the first one, the second one, and the third one. How do we increase? How do we get a better and more accurate result? One. Now Walid and Abdul Qahir and Faris. Okay. Using Ramshkuta, that's for sure. Okay. The other one, think it through. The other one, there's another clear one. Walid.
والله سعيد, the internet corruption was to me since you start the question 2. So question 2 I didn't understand it. اي والله.
Inshallah you can record the recording, but inshallah it will be enough.
Inshallah I have the lecture videos and I'm gonna rewatch your explanation here.
Okay.
Inshallah,
you can also
just go ahead. I'm not gonna interrupt you guys. So, just I'm gonna
let me know if you don't understand.
see the videos.
Thing that you don't understand. If you want to understand something, just let me know also.
For question 1 is very good. The question 2 is okay. I'm gonna just follow from question 3. Question 2 I'm gonna see in YouTube or anywhere.
Question 2, just make sure that you know this equation, huh? That's the least I can ask you. This equation, you have to know it.
Which one?
This one.
Okay.
yi plus 1.
For sure.
So then inshallah you will know how to use it. But most importantly, how you must remember that one. Okay?
Okay. For sure, inshallah.
Abdul Ghani, yes. It's not that one because we are using Euler method. So how can we get a more accurate result by repeating the same solutions? So no. Think it through. Look.
I think maybe we can. Sorry, I think maybe we can use a smaller time step.
Exactly. Decrease the step size. Because if I said, for example, this is the what's it called? The graph, compared to if I use much more points and I describe it this way. Which one is more accurate? The first one that is just like this, smaller steps. So this is the concept. Decrease the step size. By decreasing the step size, you get more accurate results. That's the idea. Okay? The third one, I even found it difficult. I had to look through the slides. So it's actually not in the slides, it's in the book. So there's other methods that are available. You have the Hines method, so you can keep that in mind in case they ask for 3. Here they specifically ask for 3, which is crazy. So just make sure you have the answers when they ask it. So the third one is use Hines method. Okay. So lastly, just to reduce stress again, we're gonna see briefly the range quota, which they never really ask. I would be so surprised if they ask it right now. So range quota is less straightforward, I would say, and it can be taken up to in any order basically. First order, second order derivative, third, fourth, whichever one. Okay, and so you have first order. Well, for us, for our case, it's second order quota because, as you can see here, we have. It is yes, okay. it's second order range quota because of the derivative here. So if you check the first order here, it mentions that for the first order, the equation takes the shape of A1 equals to, this is too straightforward, F Y1 FH. Okay, no. For us, it's actually the first order. Okay, so I get it confused. Second order quota is when they use this derivative, but the first order is when you have only this one. So you already have dv, which is here. Let's say this is already here, dv dt. And if you use the second order range quota, you get a much more accurate result, obviously. But basically, this will be dv d square, derivative square, dv over dt square. Basically, that's the idea. Is it clear to everybody? So it's the same, once again, same as the other one. yi plus 1 equals yi plus f xi times h. However, I have different values here, for example, for here. H square over 2, what's it called? 2 times 1 times 0, which is, yeah, Humes. H-E-U-M. H. Okay. So this is the essence of the second order range quota. So you have to use this method. You must determine recall the Taylor series. Okay. You have this one, y plus 1 equals to yi plus a1 k1, and this is the essence of it. They mentioned that it comes from here, the Taylor series, which is also what Euler's come from, but it's a much finer early stage of the Taylor series. So you have here yi plus 1 equals to yi plus a1 k1h, and k1h is this one, so it's the same as Euler's theory. As for when you come here, you have a k2 equals to xi p1 hi, etc. So it's much more complex in terms of calculations. In our case, we don't have this. The higher you go, the more, what's it called? The more how do we say? The more accurate it is, in other terms. And you can explore it a bit further. However, it never comes, especially the second order range quota. I don't see the use of it. It never comes in the exams. They just ask about it. How would you do it? Whatever. It's very brief, actually. For me, it came for 2022, 2023. The sample 22, 23, it came. That was 2 years ago. 2 years ago. Check. So just be mindful of that. Just be mindful of how it works. Only all comes from K2. K2 is here. Let me see. Okay. No. K2 is here. I have the calculation of K2. So you mentioned second order method or no need in the answer? Yeah, no. You don't need to mention second order specifically. Just say range quota method. It doesn't matter which order you use. It's more accurate. Yeah, kind of. You don't need to mention the order. So, clear for everybody? Okay. So we move now, just to make sure we didn't forget anything. Fourth order, OD. Okay. Yeah, this is MATLAB. Okay. So you're done now. You have the, what's it called? You have the different schematic of how to solve it, basically. Here, analytical, trapezoidal, and Euler. So different methods. For integral, you have this one. For what's it called? Curve fitting, you have this one, analytical. And if it's still difficult, in this one or this one, use Euler's. It's much easier. Okay. Done with question 2. Now question 3. Final question 3. Question 3, there is one thing that you must keep in mind is that there is no slide for question 3 on my side. Sorry. I don't know if there was a slide from your side. Did the lecturer send any slides for chapter 3, BVP? Did the lecturer send any slide? Huh? Did the lecturer send any slides? Okay. No. If you need to check, no, actually, it's gonna take time. No worries. So we're gonna do question 3 partially together. So the initial part, I already started it, and I wanted to finish it with you guys. So we have 1 more hour. Hopefully, we can finish before that. So clear? We can start. Okay. That's okay. Yeah, so this is why it's very crucial for you to see. I got this picture from the book, basically what the book says about BVP. So in BVP there is 2 methods. There is the shooting method and there is the accurate one, finite difference method. Why is it accurate? Because the book says that it's accurate, but it's actually accurate in terms of calculation as well. You can view it, but it says that for this one it uses the high accuracy formula, which is central difference approach. So this one stems from the central difference approach. Be mindful of that. So if they ask you central difference approach, or use the central difference approach, don't get confused. It's the same. Finite difference method comes from that. That's the essence of it. What does it say? It says that I prefer to start with the finite difference method. It says that for any second degree order differential equation, that means that you have, for example, d square y over dx square plus dy over dx plus y equals to 0. That's the second degree order differential equation. Okay, so this one is, it says that for the second derivative of y, which is here, it is equals to yi plus 1 minus 2yi plus yi minus 1. We'll get into it, don't worry. But the essence of it is here. Everything comes from the formula. You need to implement it, but everything comes from the formula. So just be mindful of that. The second derivative, you express it in terms of y only. So you have y here, and y here. No derivative. And so this derivative as well, the first derivative, you can express it in terms of y only here. yi minus yi minus 1. So what this really means is that if you have a curve here, starts here, x and 1 and 2, which is 1 and 2, for example, which is yi minus 1 and yi plus 1. It doesn't matter where you put your x because it's 2h, but if we were to speak simply, if you want to know the x that is here, which is the derivative is linear. Is linear usually. You just take the half, this one plus this one, or this one minus this one. Sorry, yi minus what's it called? Yi plus 1 minus yi minus 1, which is here, divided by 2. You get the value. Divided by 2. You get the value, the distance here in other terms. Okay? This usually is yi. Whatever the, what's it called? No, sorry, it's here actually. Yi. So this is xi. X and x. Okay? X and x. X at the middle here is usually xi plus 1, which is the x after it, plus xi minus 1 divided by 2. So they what's it called, use that equation to find the derivative here, because when you have a linear case, this is how easy it is to get the value. So you can just shoot it and get the fx, which is at the middle here. You have fi plus 1, fi I minus 1. Right? F is here at the middle. Just take these two, divide by 2, you get Fi. Send it on group. Oh yes. Give me a second. Okay, you already have the slide. Perfect. Okay. I'll look into it. So now that you know the two equations, to transform this second degree ODE into a normal equation and use it normally, we will go to the question. Where is the question again? I need to duplicate it. Just give me a second. Duplicate. Okay. You got the idea. So how many how many methods do we have for BVP? How many methods? You already know what BVP is. How many methods do we have to calculate what's it? One, no. Okay. So you have the finite difference method. Okay, perfect. You have the finite difference method, which is number 2 actually. You have the shooting method, which is number 1. So be mindful of that. And the more accurate one is the finite difference method. This is the most accurate. Understand? So the shooting method, we will get into it. But since this is not what I use, it's easier for me to just start with the finite element, and I'll show you how to solve the same problem using the shooting method, which is pretty simple as well. Okay. Now we get to question 3. A bar with a fixed length of 1 meter has a constant temperature of 100 degrees here. Constant, doesn't change with time. At one end, and a fixed room temperature of 25 degrees at the other end. This one. Okay. So they mentioned what else? Oh, the bar is equally divided by 4. So the length here, you can determine it by the fact that you already have 1 meter. So you know x here equals to what, x here equals to what, x here equals to what. So x is not unknown here. We have the x. x0 equals to 0. x1 equals to 0.25. x2 equals to 0.5. x3 equals to 0.75. And x4 equals to 1. Is it clear? x0, 1, 2, 3, and 4. We know, all in meter. Clear or not? For the x. No. Okay. Okay. They say that this bar is 1 meter. The length of this bar is 1 meter. So if you want to start from here, you want to go here. X equals to length. X here equals to how much? The displacement. No. We are not with the temperature yet. For now, we are just with the displacement. X here starts from 0, which is 0 meter, and ends at 1 meter because it's clear here, fixed length of 1 meter. Doesn't matter. So it's fixed length of 1 meter. Okay. So just make sure that you understand the concept here. It's pretty similar to finite element. I don't know if you have already taken it. I don't think so. So it's the same concept exactly. Yeah, see? So it's the same concept, but it's much more facilitated here because that's not the essence of it. So now I remove this x here, this here. Okay, maybe this one. Okay, so they will say something else. They say the temperature at the node of each segment is denoted as T1, T2, T3 here. Are they known or unknown? T1, T2, T3. Do we know them or do we not know? they give the value or not? No, exactly. So they are unknowns. We know that. And they give a second degree differential equation. Second degree, second order, second OD. Okay? Second degree OD. Second order differential equation. So, did they give the initial value? They say that x, when x equals to 0, when x equals to 0, meaning when x starts, x initial, x equal x0. Oh no, it's easier for me to just say at x0, t equals to 100. At xn, t equals to 25 degrees Celsius. So do we know both boundary condition, the initial and the end, or we don't? Do we know? We don't. Exactly. So here we have a BVP. That's how we know we have a BVP. They give both. So your goal is to identify the boundaries. What are the boundaries? From there you can proceed. Okay? They give this equation. This equation is related, yes, but they just said something that is different than 125. So be very aware of that. They just said that TA is the temperature of the surrounding air. So it's actually 25 since it's already there. And T is the initial and end temperature of the road. So here, what they mean by initial and end temperature, they mean in terms of time. T is not 100 here and 100 here, 100 here and 100 here. It's not that way. It's 100 here at the initial and at the end of the period of analysis. So I don't know why they worded it this way, but that's the essence of it. Huh? So be mindful of that, because the latter doesn't make sense. They already gave the different boundaries. Okay. Second of all, the fact that in the book also they have kind of something similar where they put TA equals to 20 and T0, which is T here, equals to 14. So just be aware of that basically. Okay. Yeah, here initial value problem, E0 equals 40, Z0 equals to how much? That one is something else. We'll move on to it later, but they just mean that this is T0. Initial and end, I don't know what they mean by this. So that's the essence of it. So they say for A, question A, declare the boundary condition of this rod and state the approach that can be used to solve this problem. So what do you guys think? Have you already answered the question or not? This is the boundary condition. So, okay, it's already here. So, declare the boundary conditions is already here. That is right. Now, state the approach that can be used to solve this problem. They said only one. They mentioned only one. State the approach. So, if you really look into my explanation, when we talk about approach, we don't talk about method. We talk about central difference approach. Be mindful of the term. Huh? Be very mindful of the term. Central difference approach. So the answer is not what's it called, finite whatever or shooting method. The answer is central difference approach. Okay. So the approach, central difference method. Alles? Okay. Is it clear to everybody? For question A, is it clear? Is there any doubts, problems? Okay. So B, derive 3 sets of equations that can be used to determine the unknown temperatures. Yes, yes. 3. Can you repeat this table? To approach. Okay, it's not stable, it's central difference approach. So central difference, okay, we can read these paragraphs together. They mentioned that after that form, the simultaneous, after what's it called? After substituting these equations in here, because this is here and this is here. Okay, so just be mindful of that. So after substituting these two formula in the equation, form the simultaneous equation before solving the problem using direct calculation or simultaneous method based on topic 3 in this model. In addition, for higher order ODE problem, we need to use the high accuracy formula of central difference approach. Now, central difference approach is this one. Second order is higher order. So it can, and there are other formulas for derivatives, third derivative, etc. So this is the approach, high accuracy formula of central difference approach. These are formulas of central difference approach. These are already there. Now there's additional for y, triple prime, for y, quadruple prime, etc. Okay, is it clear to you? This central difference approach is the essence of the usage of this method. So this is the method, but the approach is not finite difference, it's central difference. Okay, just to not get minus points. Stated as the book says, because I didn't check the slides yet. Maybe the slide says something a bit, says that it's the same. If it's the same, then you go ahead. Otherwise, go for central difference approach. Why did I just do that? Okay, method, approach, sorry. Approach. خلاص. OB. Derive 3 sets of equations that can be used to determine the unknown temperature at the nodes T1, T2, and T3. Now, this is where my problem lies. So, what do you understand exactly from this? What's it called? This equation. We know that dt over dx square equals to ti minus 1 minus 2. Oh, what am I saying? Oh no. Ti plus 1, okay, equals to, where is it? Okay, equals to ti plus 1 minus ti minus 1 over 2h. Can we substitute this one here? Can we substitute it? No, we don't need it. However, we also know that the second derivative, I don't know why I put x squared here. Sorry about that. Okay. So d square, the second derivative, equals to ti minus 1, well, ti plus 1 minus 2 ti plus, I believe, ti minus 1. I'll check, over 2h. This is the formula, I believe. Oh no, okay, over h square, but it's plus, okay. So over h square. H square. Now, can we substitute this one in here? That's the essence. That's the question. Okay, so this is how you know that you're following the central difference approach, because you're using its formula. This is the essence. This is the formulas that you're supposed to use when it comes to central difference approach. Okay, so they say derive 3 sets of equations that can be used to determine the unknown temperatures. Now, the problem I had with this question is the fact that they don't tell you right away to choose a method. So you're still you're still deciding whether to go for the shooting method or the finite difference method. So I don't know how they worded it so badly, but since they talk about approach, state the approach, and then you talk about central difference approach, you can go for the what's it called, finite difference. And finite difference uses the central difference approach formulas. which are this one, second derivative and first derivative. So by proxy, you have B to develop these equations T1, T2, and T3. You need to substitute this one in the equation. Now you only have it in terms of T. There's no more derivatives once you substitute it. So let's look at my answer. My answer, first of all, for the boundary condition done, and then I said that we can use a numerical method applied for boundary value conditions, either a shooting method or finite element method. However, I don't believe that this is the answer. I believe that we should go with the approach, not the method, since they asked for approach. So be mindful of that. And then according to finite difference method here, I substituted, but after translating this one into T, just like I showed you earlier, I just substituted it here. Now, why is it on the same side? Whatever. It's okay. You can keep it on the other side. It's minus, and then for me, I just put positive on this side. So there's no much difference. Just keep it as you wish. Long as later you don't mess up with the value was input. Okay. So before I jump directly into T2, T3, or whatever, because for me, I kind of jumped. I will explain briefly, no, not briefly, in detail, regarding this equation. Okay. So let's start from this one. After substituting, what did I do exactly? Okay, so we have here Ti plus 1 minus 2 Ti plus Ti minus 1 over H square equals to minus H TA minus T. Really, I believe that's it. Yeah, okay. So what did I do from here? I put this H square. Now, before we go into detail, the H here, you have to understand that there is a difference. There is a clear difference. So for this H, what it really stands for, let me check again. I kind of forgot already. It stands for step size again. Okay. This H stands for the step size. Be mindful of that. Don't confuse the two. There is H that is equals to xn once again. H equals to xn. That one so far has only been used in question 1. So you're good. Xn minus x over x0 over n. It's not the same. This one is just the step size. So how did I come about this step size? Basically, they say they said it's divided by 4. So from 0 to 0.25, etc. So the step size is 25, 25, 25, 0.25. So that's it. So just make a difference between the H that is below here. Don't send this H, don't send it here to this H and cancel or multiply by 2 to the power of 3. Absolutely not. It's two different things. So they mentioned in the equation that the H here is a heat transfer coefficient. So make sure to read it carefully, yeah? Don't get confused. It's a heat transfer coefficient. So it's different from the H that we derive from the central difference approach, because that one is numerical. Okay, so it's better to give it a value now so that we don't confuse the two later. So H equals to later. Okay, so Ti plus 1 is what exactly? Assume, no, hold on, later. Minus 2 Ti plus Ti minus 1 over 0.25 square equals to minus H. Ta is already given, it's air temperature, room temperature is 25 minus T0, which is 100. Clear for everybody, or bring to one side? Yeah, okay. No, well, I wanted to bring to one side. However, you will understand why. Because for me, I had to return it back to the other side. Okay. So this is what. But yeah, what's your question, Mohammed Faris? So h here is the distance. Is the step size once again, not the distance. This is the step size. So kind of the distance. However, if you get something else, don't get confused. Yeah, here is specifically the distance. Yes, but make sure that you keep it as step size in your head, not the distance. Otherwise, you'll be in trouble. Step size, huh? And this h is the transfer function, the transfer coefficient. Now, my problem again, especially for this case, is that it's exactly as the shooting method case. However, h is not given, so I don't know what they expect us to do. So I decided to give a value to h because there's no way you're going to solve it otherwise. It's boundary condition and it's the same case, but one h is given, one h is not given. Doesn't make sense. Okay, so we're going to go with h equals to 0.01 as well later on. For now, we keep h as a unknown entity. Okay, in the exam also, I'm sure that in their exam they have to specify h equals to what, but maybe well we only have the paper, we wouldn't know. So be mindful of that. If this example comes, they have to give h. Doesn't make sense. So now we know that T1, T2, and T3 are unknown. So how do we express them? No. Go ahead. This h. The h in the question, yeah. Heat transfer coefficient. They say where h is a heat transfer coefficient, supposed to be equals to 0.01. Okay, get it? Okay. So now, as they mentioned, they need three sets of equations that can be used to determine the unknown temperatures of the nodes T1, T2, and T3. So if you really look into this, how can you implement T1 really? So let's say that my first equation, I want to set it as Ti plus 1 is T1. Does it make sense? T1 minus 2T0 plus T minus 1. Does that make sense? We don't have T minus 1. So T1 has to be the I here. Get it or no? Is it clear to everybody? Now we have substituted already. Okay, it's clear. We have substituted the differential here, the dt squared. Now we are using this. We are substituting the t's here. So we don't know where to put T1, T2, T3, T0, and T4. We have T4. So just be mindful of that. T4 is this one. T4. T0. Just for your perusal. So back to it. Doesn't make sense. So to make it make sense, you go with T1 equal I equal T1. Okay. So you have T2 minus 2 T1 plus T0. Now, do we have the value of T0? It's possible to find T2. T1 also is an unknown. And so I advise you to actually throw the 0.5 square to the other side, because otherwise it's going to be bothering us a bit too much. So let me just remove this. So what I did, I multiply. What I'm doing, I'm multiplying this one there. I'm not multiplying by h. I'm multiplying this one by the whole other side. So equals to minus h. Now we know that the result of this is minus 75. So we don't have minus anymore. Plus h. 75 times 0.25 square equals to how much, guys? 25 times, yeah, I believe it's 18.75. Can you guys double check? 75 times 0.25 square. Is it clear to everybody? 4 point. Okay, then I made a mistake. Luckily, I didn't explain further. Okay. Let me. calculate. Okay. Then multiply the h. No need. But I think for me, I didn't multiply it by, I didn't do, what's it called? 0.25 square actually. Yeah, I didn't multiply it by, I didn't square it, basically. No need to multiply by h yet. Okay. So we have here 4. Yeah, see? So this is my problem. So be mindful of that as well. So I haven't made a mistake regarding that. So 4, oh sorry. 4.688 h. Okay? Simple as that. Now, is that an equation? Can we consider this an equation? Yes, we got square. Okay. Can we consider this as an equation? Okay. So equation 1, we note it. Number 2. No, why it erased. Number 2. Number 2. Equation number 2. Now I move up. Before T2 was I plus 1. Now, if I use T2 being I, we have T3 minus 2 T2 plus T1 equals to 4. They're all equal to the same thing. 4.688 h. They're all equal to the same thing because this is a constant. All this is constant. And so T, but you will see the difference soon. So T4 now minus 2 T3 plus T1 equals to 4.688 h. Does that make sense? Oh, sorry. Thanks. Hey, mashallah, you're paying attention. Inshallah, you get full mark too, man. I'm looking for that. Yalla. T2. Okay. Now, does that make sense or not? Does that make sense? Okay. No problem. Now that we have an equation, we are not fully done with it because you need, just like your friend mentioned, that you need to put it in the form of matrix. Now we can substitute the h being 0.01 now. Now calculate it with h. No, well, it's already obvious. First of all, yeah, h being 0.01. You can calculate it. 0.01, which equals 0.01. We'll have here, for example, this. Okay, alhamdulillah. So with h.01, it is just equal to 0.0446. Hold on. 469, right? 469. Right or wrong? I believe this is what we receive as a result. Faris. Okay. H, I just got it from the book. In the book, they have the same case. They say that in this example, you have t squared, you have h ta minus t, and you have ta equals to something, and t0 equals to something, and then you have t end equals to 200. Ta is room temperature. T10 is the t at the end. That's 10. When L equals to 10. Okay? And they put H equals to 0.01. H prime equals to 0.01. So for me, I'm assuming that H has a value. It has to have a value for you to be able to solve it. That's the essence of it. So for you to for you to be aware of it. That's the essence of it, okay? Has to have a value. However, we didn't put it. They didn't put it in the question, basically. I don't know for what exact, whatever reason, they didn't put it. And so the T here is the initial value problem, which is 40, and the H here is the heat transfer gradient, which is 0.01. Is it clear? I just took it from the book to make it make sense, but really, I strongly believe they often make mistake with it. Even for my case, they have made a lot of mistakes during test one, so they often miss some information. So just be aware of it. If you're stuck in the exam, make sure you inform the lecturer, because sometimes they just do it quickly. They don't even know the answer. I believe you guys heard of my story with test one. It was a whole nother problem. So now that we know that it's 0.0469, okay? Here, if you pay attention, T0 is not unknown. But also T4 is not unknown. Right or wrong? So now you are in this case where you have -2. This can be translated into this. Let's see. This -2 T1. I prefer to put T1 at first here at the beginning. -2 T1 plus T2 equals to, I put it here, equals to T0 is actually minus T0. T0 here is what? 100? Yeah, here. T0 is 100. Here. So we have minus 100. So minus 100 point. I don't think it makes such a difference, but this is just an assumption, guys, once again. But the H there, they surely gave it. That's for sure. Okay. Then you have here for the second equation. Where is T1? T1 is here. What's the factor? Just 1. So you put T1 plus, minus 2 T2 plus T3 equals to 0.0469. And then you have here, lastly, do we have a value for T1? Here, T1 doesn't have a value here. So we only put T2. I like to keep it here because just for the sake of the matrix, basically. T2. Hold on. T2 minus 2 T3 equals to T4, go to the other side, turns into minus, so minus 25.0469. Simple as that. Is it clear to everybody? Okay. Alhamdulillah. Now you just note them as equation 1, 2, 3. Yes, now go ahead. Astaghfirullah, yes, you're right. Oh, mashallah. Hey. Okay, so it's minus 99.95. Okay, so just put minus 99.95. It's 99.95. So I guess same goes for the other one, right? 24.95 or something like that. Okay, minus 24.95. Okay, clear. جزاكم الله خير يا محمد فارس. يلا. Now we can we transform it into matrix? What makes you think that we can transform it into matrix? What makes you think that? Do we have enough equations? What exactly is the reason, basically? What did we do to be able to transform it into matrix here? We transformed it first into simultaneous equation. That's the most important part. Simultaneous equation first. Okay. We have three unknowns. We have three equations. It's possible. So we can start here. The first one is, as you can see here, -2. What's it called? Walid. Be very mindful of this, huh? Now I'm doing step by step your question and sorry, your concern. So this is what we were talking about from the beginning. You asked about. So now we transform it into matrix, huh? So we have -2 for T1. Also we have 1 for T2. For T3, we multiply by what to have nothing? By 0. Okay? Clear? Then close the bracket. Later, that's another compartment. For the second equation, we have for T1, you have 1. Okay? For T2, you have -2. For T3, you have 1. Once again. Okay? For last part, I have 0 for T1. I have 1 for T2. I have -2 for T3. This is quite interesting because it's just, as we call symmetric, as we call matrix. So you have T1 here, you have T2, and you have T3. Equals to what's it called? -99.95, 0.0469 minus 24.95. Allah, can I have an answer to that? Can you guys calculate it? You know how? Simultaneous equation. So what do we got?
I got for first one 81.17.
T1 equals 81.17. Okay, perfect.
For T2, 62.4.
62.24.
Wait, just 4.
1.4. Okay.
Yeah.
Then
For
T3,
T3, 43.67.
3.67.
Yeah.
Okay. So does that make sense or no? We go from 81, it decreases to 43, which is realistically here. Goes from 100, then goes to 81, 62, 43, then 25. Does that make sense? Exactly.
Yeah, it makes sense. Yeah, because like it's moving now from one place like to there.
Yes, exactly. So this is why I say you need to be aware of these two equations, dtx and d to the power the second derivative, basically. You need to be aware of these two, because from what I understand, they don't give you the equations. So for the question 3, memorize these two. At least if the shooting method is difficult for you, just convert the equation into these two. Just substitute and use it. Very easy, very simple, very direct. Understand? Now you got here. Actually, we did two at the same time. We did B and C. We were only supposed to derive. So we derived already the 3 sets of equations. So this comes down here. And then now, Faris. What I assume the right side is always HTA minus T. Okay, this is the problem. For me, as the one giving you the information, it's risky if I tell you, yes, this is how it is. Meaning, I don't know if they will bring a case as simple as 24 to 25 semester 2. Because for me, it was again about the heat. Yes, it was about the rod. Okay? But for me, they had FX, they had the same thing, okay? Here, we have the equation they gave is this one. dt over dx squared equals to minus 0.12x cubed plus 2.4x squared plus 12x. So is it fair? Oh no, plus what is this? Plus 2.4x squared. So it's not fair if I tell you that the other side is HTA minus T. Because then you come to the exam and you have this equation. Now what do you do? Understand? So what is fair for me to say is that whatever the value they give on the other side, this T, we need to transform it into this. You need to substitute, and then you substitute it. And then whatever the value of x is, x will be given. X, you will know it. You have the step size. You will be able to know x. What you won't be able to know is t, the t1, t2, t3. So that one will come from here. Whatever the equation they give on this side is easy. But on this side, you need to remember. For us, I don't think we needed to remember. We brought the whole book. So I'm very surprised. But alhamdulillah, your test is quite easy compared to ours. So there is balance, alhamdulillah. So don't just assume that it's always like this. They can be a cubic equation. Yes. Go ahead again. So for this one, both h and x is the steps. No. Okay. Okay. H here is just an equation that they is from the equation that they brought, meaning they put this formula here. H here is H. They put it. However, for this H, if you see in my question, in my answer, I translated it into this one, delta x, to not confuse the two. Okay. So I don't advise you, if you find H here, to just keep the formula here as H. I advise you to just change it to delta x, or you can understand. So I don't know which x exactly you're talking about, but the H that is in the formula given by the exercise is not the step size. Now I am talking about the example, the H square. Okay, H square is the step size, 100%. For my example, the one that came to my test, yes, the H was the step size, 100%. You're right, correct. Okay. So we are almost at the end, alhamdulillah. Is it clear for everyone? Until C, using numerical method of your choice. Which numerical method did we use? We used finite difference method. Clear? All of us. So now using, let me just note it here. Using finite difference method. No? No, 15 minutes, inshallah. Okay. Yalla. So, lastly, question D. We have done B and C. D. Do you think that the answers you obtain in C is accurate? If not, explain how you can improve your answer. If yes, explain your reasoning. Now, I need you guys to answer it. 100%. I'm not going to help you with this one. What do you think? What do you think? Is our method accurate, or we can improve it?
I think our method is accurate.
Accurate. Okay, perfect. So yes, just like Muhammad Faris says also. Yes, it is accurate. And why exactly?
Because like it clearly shows that the heats are moving from the initial to the T0 to the other point. So it's going to be like difference on temperature from every point.
Yeah, because it makes sense. It's kind of an argument, but not the key points. Meaning what you can put it, but they will ignore it because there is no mark on that sentence exactly. That's not what they're looking for. Okay, since you answered it, it's okay. I will still happy with it. Yeah, Muhammad Faris, do you have any idea why is it accurate? why exactly is our method accurate? What is your reasoning behind it? Alright guys, because we use the high accuracy central difference approach. Exactly. Now you understand, huh? Because we use the high accuracy central difference approach. So, because we used the high accuracy difference approach. Okay, now that we are done with D, well, this is so simple. This is already 6 marks right there. Very easy. Okay, now that we are done with D, I'm gonna briefly speak about shooting method. Okay, what exactly was shooting method? Shooting method basically, they transformed this second derivative into a first derivative, and they came back to the initial value problem. Now, do you remember the initial value problem? So let's say that dz over dx equals to this formula, and we have all the values. Okay, what does the initial value problem says? It says that for z1 equals to z0 minus h. H here is the step size, so I will remove h here, and I'll put what's it called, this one. Okay, x okay, times h t minus ta. That's what it really means. Understand? This is what it comes down to. Step size, you have z0. What will be z0? This is what we are talking about. Now, for their method, they use range kuta, so it's quite difficult. Which is why we don't what's it called, ask you to use the shooting method in the exam. However, they will ask you to explain how can this problem be solved by the shooting method. Which is why now we need to have, this is nice. We have two approach, analytical approach and central difference approach. So just for your information as well. So range shooting method comes from the analytical approach. So how will you use the what's it called, shooting method? You need to be able to read through here. Okay, they say what the shooting method is a method for solving a boundary value problem by reducing it to the solution of an initial value problem. So how the problem can be solved by using the shooting method? It is by reducing, by reducing it to the solution of an initial value problem. Guys, be very mindful of that. That's the key point for the shooting method. It is the fact that you reduce the equation, the secondary differential equation, second order differential equation. You reduce it to a first order and use the initial value problem, which has been detailed here so much. Let me see. Yes, it has already been detailed here. Now you can use the Euler's method as well. It's not so limited. However, we need to have the value of z0, which is the initial value condition, initial boundary. So for us, we know that what's it called, is 100 is constant. Okay, 100, they mention in our case that it is constant. Where is it exactly? Let me show you. Yes, a bar fixed length has a constant temperature. So if f of x is constant, derivative of f of x is what? 0 by default. So since the t here is constant, then the derivative will be constant. What is the derivative of t? Derivative of t is here, equals to z. So we have an initial boundary value condition. Again, let me make it easier for you. If I ask you, hey, you need to use the accuracy value, the analytical approach. Use the analytical approach. The analytical approach. What you should be able to do is say that, oh, this t square over dx equals to dt over dx times dz over dx. That's what they are saying. Oh no, hold on. No, Safla. It's the hold on. Okay. I'm getting confused. Okay. This secondary derivative is equals to dz over dx. Okay. Therefore, if you integrate both, you have dt over dx equals to z. Is it clear? Is it clear, guys? If dt, secondary derivative of t, equals to derivative of z, derivative of t equals z. Does that make sense? Okay, that's what we assume in this problem. So what we really do here is we mentioned that for at t 0 equals at t 0, we have t at x equals to 0, we have 100. However, 100 is constant also. So also delta t x when x equals to 0 is 0. If this is constant, this is 0 derivative. Is it clear or no? Is it clear, guys? Okay, it's 0. So by proxy, we have the initial boundary value condition of z equals to 0, because we assume that dt over dx equals to z. So you also know that z equals to what's the name? Okay, h t minus ta. Here is t minus ta. In the exercise it was ta minus t, so be aware. So we assume that z at 1, z1, this is z0 equals to 0. z1 equals to, using Euler method, we have z0 plus or minus, I believe. Using the Euler's method, what does Euler method say? It says that it's plus step size. Don't get confused. Plus step size factor of this. We have h, which is really, oh no. We don't have this. It's not z. Actually, dz over dx equals to this. Z equals to dt over dx. Now dz is the same as this one. Okay. So we use this one. So is equals to step size times dx dz over dx. Simple as this. However, here you will consider z 0. Wherever you see z, you use z is 0. But this is a constant, so you don't need to worry about it. So it's just Z0, which is 0, minus step size, which is equals to, or step size times whatever this is. So step size was 0.25, and so this constant I believe was 0.00468. Sorry. Okay, just like that. So Z1 equals to this, Z2 equals to this, Z3 equals to, okay. After this, from there, you know, okay, you have the value of Z. How do you come about the value of T? Likewise, you have dt, initial boundary condition, you know, use Ti plus 1 equals to Ti plus H D T over dx, which is Z, which is a constant. Understand? I don't know if I'm too fast with you guys. So this is the run scooter. However, you don't really have to learn it really. I never seen an example where you have to do it. Even when back then when I was studying for it, I never had to use it. But, no the shooting method. So just be aware. So this is just for your information. Z equals to constant. So this is just how easily you find Ti basically, because you have here you will start by T1 equals to T0 plus H step size once again times Z Z0 for example, which is here 0 also. Understand? Simple as this. Whew. Now the accuracy is different once again, because this is why we call it shooting method, because the accuracy is actually very different. So the more accurate value is, like we said, a more accurate approach is central difference approach. Yeah, it's very complex. This is why I advise you to look into it in terms of theory. Just make sure you know what approach this is, which is analytical approach, and then you're good, inshallah. Most importantly is the fact that you memorize this equation, these two equations, derivatives, first and second derivatives, so that whatever they give, you can substitute it in the equation that they will be given to you, just like this one. Hopefully everything was clearly understood. So let me know if you need any other sort of explanation. Is it clear to everybody how we solve this sample, basically? Okay, so you have curve fitting, have differentiation, have integration. Differentiation, I guess what I advise you to do is to check out the simple method. There's already a simple method in the slides I've sent. There's a simple method. So I'm not so worried about it because it should be as easy as the integral one. Just make sure you understand the equation. You practice at least one exercise, guys. One exercise at least for every single one of them. And inshallah, you get full mark, guys. Because it's actually very easy. Huh, guys? Actually,
Yeah.
very, very.
Like I want to mention like one last thing. I think for the BVP, I heard some rumors saying like there will be beam deflection.
Okay, beam deflection is the same. They will just give
Like
you the.
you're gonna use like the shooting or the other one?
No, I always advise you to use the other one. Shooting is not really going to help you. You have all the information you need to. Shooting, you need to take this equation and convert it into an initial value problem. So what's the point? Just use the other one, continue with the boundary value problem, and you have already the initial and the final values. Just use that.
Because like, on the slides, I saw some work it deflection, and they were using the finite one, the second one.
finite one. Yeah. Usually that's what they expect you to use as well, because the shooting method, if you've already done question 2, you already done initial value problem. So why do you come to question 3 and repeat initial value problem? So they usually expect you to use this finite difference method.
Okay, and for the second question, like we have two methods, Euler and the one range quota.
Yes, range quota.
Like, and you mentioned like they probably not gonna give you range quota because it's so long, a little bit.
Yeah.
So like maybe we can put our force on Euler, right?
Yeah, always.
Okay.
I have yet to see them put what's it called, range quota. They did, but not to the 4th degree. It's just the 2nd degree, and they already give you the values necessary. So you just follow the equation. No, Faris. The differentiation for question 1 is Simpson on 3rd rule, or no. All of this is 2nd question. Oh, Safallah. Let me check again. Okay. The question 1B. Okay. The differentiation for question 1. Differentiation is no. This one is integration. Yes, exactly. This one is integration. Let me just open briefly the slides for differentiation. This one. So you have this one. Yeah, we get to my nerves now. Okay. So you have these, you have, I believe, 2. Oh no, yes, see, only have 1. Final difference approximation, which is pretty straightforward if I remember. The tables, expansion, bring effects one side, this side, they combine, first order differential equation. Example. Yes, so first order for differential equation. The difference. Yeah. So you have to derive the values. Yes. Here, basically, you have to derive. You have to derive it using this equation, and then the derivative basically of your function is equals to f(x plus h minus x), and backward difference, central difference, multiple equations for what exactly? So let's try accuracy increase or intelligence. That's all okay. Forward difference. Okay, let me check. From what I understand from my calculations, you need to follow a method of this method. Yes. Okay. Central difference. Yes. This one. You just need to follow this one. Depend. If you need to do the 2nd order, or so all of this is just like the question 3 where you have the differential equations. So you are already given f of x plus h, f of x minus h, and 2h. F of x plus h meaning, it literally means the same exact thing as this one. It's exactly similar to what you learned here in differentiation. This dy. Yes, this one. You just use this formula. Understand or not? that's the differentiation. Numerical differentiation. That's what it is. Is it clear, guys? So subhanAllah is actually very easy. Everybody. Okay, see? So you just follow the slides, but don't rely too much on the slides in terms of understanding, because it's very difficult. But you check past papers, corrections, and how they implemented it. But for the numerical, chapter, basically to summarize it is this one. That's a pretty simple way to summarize it. So there you go. You have the numerical chapter. Any more questions? Walid, who else? Ibrahim, I don't know if he's still here. Medical. لا خلاص. طيب يا شباب, it's already 11 p.m. I don't want to hold you guys for so long. You have exam tomorrow. So do I. So may Allah make it easy for everybody. And inshallah, you guys get full mark. Everyone, yeah? Everyone. You have the possibility to do it. Most importantly, make sure you have enough energy. Don't what's it called? Spend the whole night studying and in the morning you're tired. Because you actually need a lot of energy during the exam. So make sure you simplify your steps. Make sure you simplify your steps. Don't waste too much time if you don't understand. If you don't understand, move to the next one. Move. There's no time to think. If you haven't tried this type of exercise and you're surprised and you're caught, you don't know what to do, move to the next one. When you're sure that you responded to every question you knew for certain, you come back to the question you don't know. That's the idea. That's the essence of it. And make sure you practice. Once again, make sure you practice. You don't have the equations with you. They don't provide you the equations. I'm really hoping that you can do it, inshallah. 1 hour, 30 minutes is nothing. And may Allah bless everybody, inshallah. So see you soon. Let me know how was the test. Make sure you to prepare very well. Assalamu alaikum wa rahmatullahi wa barakatuh.